All right, so this is your homework of the basic questions. Sorry, there were some mistakes with the questions. It was corrected already, so they are now solvable. Now, anyways, the key idea you need to take away, okay, the first 50% is SVA. What's S, what's V, what's A?
Displacement, velocity, acceleration.
Yes, all right. How do you go from displacement to velocity?
Differentiate.
Differentiate. How do you go from velocity to acceleration?
Differentiate.
Differentiate again. So of course, if you walk backwards, what's the opposite of differentiation?
Integration.
Integration. So that means integrate to go from acceleration back to velocity, and finally from velocity back to displacement. Okay, good. So now this is just the the first 50% of mechanical stuff, and you can solve a lot of questions already, right? You realize it's just differentiate, integrate. I'll leave you to check the careless mistakes you made over in the workings on your own. I sent you the file already. Can? Like integrate 3t square. Is it 3t? No, it's t cube, right? This kind of small mistakes, I will leave you to work it out on your own. Let me know if you got any questions.
Okay.
Right, you get it, right? Okay, good.
Those are careless mistakes.
Yeah, careless mistakes.
How do you know?
I mean, you probably differentiated this. Actually, also I'm not very sure. If you differentiate this, you get 2t, should be a 6t. How come you get 3t? So it's entirely mistake. I don't know careless or not. It's definitely wrong.
Okay.
All right. Yeah.
I'll look at it.
Yeah. Then sorry for the mistake here. The question I've left out a t cube there. Without it, the question can't be solved. Yep. So you get updated version, then it should be solvable this time. All right. Then here there's another trick I made. Over here, even though you differentiate this, you get positive t squared minus 4t plus 2. In the original question, it's actually negative t squared, positive 4t, and negative 2. You see it's different? Right? So that's why all of your questions, I think you thought that they were the same, but actually it's off by a negative sign. Haha. So everything else, you must bring in the negative sign. Okay, I'll leave you to check the mistake on your own. I tried to do a little bit of correction for you already. You can go and read it on your own, right?
Okay.
Good. So that's the first 50%. The next 50% of the kinematics topic, right? Let me bring you to the notes now. Yep, here's the notes, last chapter. That's only bullet point 1. You can only solve some questions with it. Not good enough. You need to move on to the next half. This half. Okay. Help me to okay, let's just read it together. What is displacement defined for you? S is defined as distance moved by a particle in a specific direction. So I think I briefly mentioned this before already. The difference between distance versus displacement, scalar versus vector, right? So over here, displacement is a vector, so there is a positive and negative sign. Could you give me like 5 seconds? My iPad is not responding. Or is it notability? Can you see my shared screen?
Yep.
Okay, it is frozen on my end. I am not sure why. Is it showing?
Yeah, I see it.
Oh, okay, good. So what was I saying? I was saying that displacement versus distance, they are different because one is displacement is a vector, whereas distance is a scalar. So let me just write this down. This guy is vector, whereas distance here is a scalar. Okay, what's the difference? Vectors can have direction, have an extra property of direction. So here in this topic of kinematics, we are only looking at 1D, one-dimensional kinematics. So a particle will move left or right. Of course, you can also think of it as up and down, but it's only along one dimension. One dimension means along a straight line, either vertical up, down, or left, right. Okay? Most of the time, the question won't tell you it's moving left or right. You just have to draw your own diagram. Okay, they only tell you the functions. Is that okay so far? The concept, Good. So the next idea is velocity. Velocity is defined as the rate of change of displacement. Rate of change just tells you what do you have to do? Differentiate law. Oh, you have to differentiate. Why is my okay? Rate of change just tells you that you have to differentiate it. Okay, good. Now here they also tell you something. V, it can take on positive or negative values. So can you help me to write this down? Help me to write this down. Let me zoom in for you. If V is finite, don't exactly need to know what finite means. It just means not infinity. Okay, it's an actual number. More than 0 means that it moves rightwards. Less than 0 means that it moves leftwards. Okay. Write this down. Then done writing, copying.
Yeah.
Okay, so what but this right and left, right, it doesn't have to be the case. Okay, as we move on to engineering and physics, when you study kinematics in more detail, you realize that these are arbitrary, right? Because one dimension, you have two possible directions, either go to the left or to the right. Here, by default, we usually assume that more than 0 is rightwards, less than 0 is leftwards. Of course, you can always swap it around, depending on how you view your world, your frame of reference. So I don't want to talk more about that because I don't think I'm qualified to talk about it. Frame of reference. Wow. Right and left. So for now, we just assume that V more than 0, move right. V less than 0, move left. Is that okay?
Okay.
And now, you can also interpret it as up and down, right? Usually with more than 0, it will be up. Less than 0, it will be down. Just like the positive and negative y-axis. And positive x-axis and negative x-axis. Okay, good. Moving on. Next one, acceleration. Acceleration now becomes rate of change of the velocity. So previously it was rate of change of displacement. Now just change it to rate of change of velocity. You differentiate again with respect to time. D by dt, right? So, I see. Every time I change from highlighter to pencil, it will have a bit of a lag. So A equals to dv by dt, like this, right? Then the previous one was V equals to ds by dt. And S is just itself. Okay, so here when they say A is more than 0, acceleration occurs. When A is less than 0, deceleration occurs. Can you see my highlighting? You see?
Yep.
Okay, so what does it mean when you accelerate? Just imagine you're on the MRT, okay? If you're on the MRT, you're ascending. It stopped at one station already, and then it decides to move off. Okay, it decides to let me think, move in this direction, right? When it starts moving from when it's not moving, the v is equal to 0, velocity is 0, right? Then eventually, as it starts moving, the v will increase. Let's say it raises to 1 meter per second, 1 meter per second, right? But in order to do that, there's an amount of time that passes. Like let's say 0.5 seconds. Then there will be an increase of 1 in the velocity over a period of 0.5 seconds, which means that the rate of change of the velocity with respect to time will be 1 over 0.5, which is 2, right? Then that will be acceleration, roughly speaking, average change in velocity. So that's sort of 2 meters per second. And if it is a positive 2, it means that you are accelerating. You're going faster. Okay? Is that okay?
Well,
then what if it's A less than 0? A less than 0 means you step on the brake. The MRT is currently going very, very fast already. It's already halfway between two MRT stations, but you decide to press the brake. Then what happens? Whoa, you suddenly have an inertia, right? Then you jog a bit when they step on the brake. And that's when you decelerate. That's when A is less than 0. Now, question, can you have V more than 0 and A less than 0? Okay, where is the pencil? It's not loading. Okay, up here. When V is more than 0 and A less than 0, is that possible? V more than 0 means what? You are moving rightwards with a positive velocity, and A less than 0 means you're decelerating. Is that possible?
Yeah.
Yes, exactly. Of course. Just imagine the MRT. You're moving towards the right. But let's say, here's how it goes down. At first, you're moving very slowly, like this. Slowly, slowly. Then suddenly you move very fast. And then eventually in the middle, you're going at a constant speed already. How do I draw this? How do I draw constant speed? So the distance between them must be equally spaced apart. right? And then finally, you start to slow down. You slow down, and you bunch up together. Maybe this part should be more equally spaced out. Right? Eventually, you start to slow down. But you're still moving rightwards, right? Imagine MRT station, MRT train. It can only move one direction. V more than 0 move rightwards. That makes sense, right?
Yeah.
Okay. So many different combinations of V and A can be V more than 0, V less than 0, A more than 0, A less than 0. All of them are possible. Okay, all of them are possible. All right, then let's continue with the 5th point, which is a few of the different keywords you'll see in the questions and how do you translate it into the corresponding variable. So when they say initial, like the initial position or initial displacement, initial velocity, initial whatever, you need to translate this English word into t equals to 0. Okay, it's already written there. I don't need to write it. T equals to 0 at the beginning. Okay, right. This one you know. I've seen you're working. You know this. Next one, at rest. This one I haven't introduced yet. So at rest means that v is equal to 0. Your velocity equal to 0. So can you tell me, can you give me some examples of a particle? Just think of it like a car or something, or MRT train. When is the v equal to 0?
Like when it's not moving.
When it's not moving, right? That's one possibility. That's actually stationary. That's actually stationary. Oh, sorry, no. At rest. Yes, correct. At rest. But there is another scenario where v is also equal to 0, which is the next line, when the particle is what they call stationary. Where have you heard of the word stationary before?
Like nowhere. Like, I don't know.
Does this sound familiar?
Testa. I thought the S is solve.
No, not the S. Okay, what's this whole procedure? In particular, the TA part.
Table.
Table to determine what?
Or to determine max or min point.
Also known as what kind of points?
Stationary point.
That's when you heard of the word stationary, right? Stationary points. So why do they say that when it's stationary, you get v equal to 0? The reason is, let's imagine this is the S graph against T, the displacement. So displacement can be positive and negative. So imagine if this was sine x, goes up, it goes down, it goes up. Sorry, not y. It should be S equals to sine of T. What this is describing is, as time progresses, your displacement is positive until eventually becomes 0. Means you go back to the original point. And then negative means you move towards the left. Just now positive means it's moving to the right. And then eventually it goes back to 0. Okay, so it moves to the right and it goes back to the original place. Then it moves towards the left and then it goes back to the original place. Okay. So can you tell me what happens over at these 2 points? Let's say this guy here. This is the minimum point, right? Also known as a stationary point. Stationary got 3 categories. Stationary point got 3 categories. What are the 3 categories? Min, max, and inflection point. Inflection point. So minimum point looks like a sad face. Sorry, other way around. Minimum point looks like a happy face. The minimum. Maximum point looks like this one. Inflection point means this one or this one. When you have a change in the curvature from left half of a sad face to a right half of happy face. Where's my highlighter? Like, okay, this part here. Left half of a happy face to the right half of a happy face. Sorry, let me try that again. Left half of a sad face to the right half of a happy face. And for the other one, it's the left half of a happy face and the right half of a sad face. Right, you change from happy to sad or sad to happy. Right, those are the 3 stationary points. But here, if we pay attention to this S graph, right, the displacement graph, you notice that let's focus on this guy, Are you okay? Can is showing. This guy is a minimum point. So how do we find the minimum point? That star, right? So what do you do as your first step? You differentiate. Differentiate what?
Displacement.
So you differentiate displacement, but it's a function
We
of time
get
t by
velocity.
but that's velocity, just a coincidence. And that star procedure tells you to D for differentiate the S with respect to T, E for equate it to 0, and then from there you solve. Oh, what you realize is V equals to 0. Right? Oh, you pointed at it. Okay, you get it already?
Okay.
No? Oh, this is my writing. Sorry. So, yeah, you're just following the Desta procedure on the S graph. And just so happens that the derivative of S happens to be V, and you need V to be equals to 0. So you have a V equals 0 here. Okay? Okay. Very good. So now that we have clarified this, we can solve a lot of questions already. Let's continue with 3 more points. Next one, particle is at a fixed point. Okay, when it's at a fixed point, it means S equal to 0. Okay, S is a measurement of how far away you are from a reference point. Maybe help me to edit this a bit. Should be fixed point O. Hold on a second. My screen is lagging a lot today. I think the Wi-Fi is not good. Help me to write this. Particle is at a fixed point, comma, O. Usually O can be other letters, but usually O for origin, the starting point. So if you're at the starting point, the S is equal to 0. This is a letter O. Is that okay?
Okay.
Next point. If you see the phrase in the question, maximum or minimum displacement, maximum or minimum displacement, that means V equals 0. Why? Just look at the example.
V equals 0. Max this O, cos O, okay, it's at that point.
Yes, exactly. The maximum and minimum displacement is the maximum point and minimum point of the S graph. And how to find maximum minimum? Follow that star procedure, which requires you to differentiate S. But you already know derivative of S with respect to T is V. And the E of the Desta procedure asks you to equate to 0 to find the turning points or stationary points. So again, it will be V equals 0. Okay, so even though they talk about displacement here, which is S, you immediately link it to V equal to 0. Okay?
Okay.
Yeah, so it's a bit indirect. Even though they are talking about displacement S, you have to think of V. So this one really need to understand the concept a little bit. Okay, then the next one will be maximum or minimum. This time instead of displacement, it's velocity. So using, okay, let's say that the graph of the velocity happens to look like, okay, the lag is real. Give me 5 seconds. Okay, let's say can you see my screen now? Okay, good. So let's say the velocity looks like this. Say, I don't know, a quadratic curve like this. Right? So positive here, negative here, then positive there. So when we say we have a maximum or minimum velocity, let's say it's this point here, this is a minimum velocity. How do we, what does it mean? What does it mean? If you want to find that minimum point. Yes, the derivative of V, which happens to be A. The star procedure asks you to equate it to 0. So therefore A equals 0. Yeah, then from there you solve, and then you can determine nature, but don't need. All right, Ken?
Okay.
Yeah, good. So even though they are telling you about velocity, you must think of acceleration. Even though they're telling you about displacement, you must think of velocity. So it's a little bit indirect. You think of A, S, you think of V. Don't be sad, it's okay. All right, so is that enough? No, there's still few more important ideas. Number 6 and number 7. Number 7 will be the step-by-step procedure that's usually required for you to solve questions. So one more definition out of the way. So number 6, average speed equals to total distance traveled divided by total time taken. Please pay attention to this guy here. It is distance, not displacement. Okay, not displacement, which is In other words, it's not just S of t. Okay. How do you find distance then? If displacement is not distance, but we are only given S, V, and A, right? And S is the displacement. How do we link displacement to the distance? So let me just give you a short story first. This one is a crash course in the difference between displacement and distance. You should have learned this from a physics class.
Video. Oh.
The video as well. The video as well. Let's say that you
the last part.
Yeah, the last part. I think they were drawing a ball dropping down from a ceiling, right? Or something like that.
I thought it was a train.
Oh, it was a train? Oh, okay. Maybe I remember the wrong video, but okay. Let me just try and explain to you how I interpret it. So let's imagine that you have a straight line here. Then this is a point O as a reference point, the origin. Then there's a particle here. It moves towards the right, okay, like this. And then once it reaches this point, it makes a U-turn. I know what you're thinking. U-turn means that it's a semicircle shape. Maybe you need to use the circumference of a circle divided by 2 formula to calculate distance. No, don't need. You don't have to think that way. Just think of it like a MRT. The MRT is along a straight track. How do I draw a train? I don't know how to draw a train. Something like this. This one different country already, not Singapore. Got smoke coming out. Okay, this one train, it only moves left and right. It cannot make a 180-degree turn, like along a semicircle shape path, right? So think of it like this. The particle is over here. Then can you see I'm moving it towards the right?
Okay. Yeah.
Right. Oh, maybe I should show my screen like this, easier. Let me go back to the original place. Move, 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 until eventually you hit the right side. What happens is you don't make a turn, you just immediately move left instead. Possible, right? This situation. Okay, you'll be seeing it later. Let me change back to presentation mode. So now, if I can get my iPad to not lag, after I hit this point, I have to U-turn back. So now let's say I move all the way to the left, like this. Okay, and then I hit another point, and then I decide to move a bit more to the right. So now, can you tell me? Let me just label some of the distances. Let's say that this distance to this point to this point is, let's say, 3 meters, and this distance here is 2 meters. This distance here is 10 meters. Okay, can you tell me what's the distance traveled by this particle? Let me just be consistent and use red color. You start at point O, you go to point A, you go to point B, and then you go to point C.
28.
Let's see. Actually, I haven't calculated this. 15 plus 10, 25, plus another 3, 28. Yes, correct. That's the distance traveled. Okay, so what you see is that distance is different from displacement, because now, let me just write this down first. Distance equals to 10 plus, okay, I'm just gonna write 15 straight away, and then plus 3, this is 28. But the displacement in this case, what is it?
It's 2.
No, it's -2.
Oh.
Because it's towards the left. Okay, towards the left, then it's -2 meters. Okay, you take the original position, the final position, you measure the horizontal distance between them. Why is my highlighter not showing? Okay, here is the original, there's the final destination. You check the shortest distance between them, which happens to be 2 meters, but it's towards the left, so you have to say -2 meters. Does it make sense so far? Okay, good. So distance and displacement is different from this picture. Okay, let's take a look at this procedure, a 4-step procedure. How do you find distance traveled in the first n seconds? So what you do is, first you let v equal to 0 to find t. What does that help you to do? When v equal to 0, it essentially means, if you look at, let's say, this picture, let's say we look at this picture over here. When v equal to 0, it's really just the maximum and minimum points. Agree so far? And the maximum and minimum points is really just telling you that it's a turning point. What does it mean when we say turning point? It literally means that the particle is turning around. It literally means that the particle is turning around. Hold on. Let me get my pen if I can get my iPad to respond. Okay, so here it goes this way and then downwards again and then upwards again. How do you translate this into a picture? Let's say this is +1, there is -1. How do you translate this displacement graph into a picture? Here's how you do it. You draw a horizontal line like this. Let's say that this is the original point. What happens is the particle moves from s equals to 0 until s equals to, let's say, +1 here. And this coordinates, let's just label some of the coordinates. So it's pi/2, 1. That point there is pi, 0. That point there is 3pi/2, -1. And then finally it's 2pi, 0. What it means is, if you look at this diagram over here, from 0 to pi/2, it moves towards the right until it hits a distance of 1 meters away. Here. And you hit, maybe I label a point. This is point A, sorry, can you see the point A?
Yeah.
Point A here, point B, point C, and then point D. It's getting quite messy. Okay, it's getting quite messy. Let me draw it somewhere else. I don't need all the details. 0, 0. pi/2, 0. Pi, oops, that's not a 0, that's a 1. Pi, 0. 3pi/2, 3pi/2, -1. And then 2pi, 0. 1 here, -1 there. This is y equals to sine of t. Sorry, s equals to sine of t. So in terms of the diagram, what it means is we have a line like this. Here's the origin. From here to here, this first half, we are traveling from time t equals to 0 to time t equals to pi/2, distance of +1 meters. So a particle maybe is over here. It travels until it reaches this point here. Let's call it point A. Point A. Okay. Then what it does is it makes a U-turn like this. This dotted broken line here, over here, it's not significant. You do, it's just to illustrate only, so that it's easier to draw the diagram. I'll draw an arrow this way to represent the direction. I'll use a solid line. Then what happens next is when you go from the point A to point, let's call it B. Okay, the red color one. Or maybe I'll just be consistent with the color. This part is pink. What happens is that you're going from +1 displacement until you hit 0. Can you see? From 1 drop to 0.
Yeah.
So if you have 1 drop to 0, what it really means is your particle moves back towards the origin this way. Can you visualize this?
Okay.
And then after that, let me use a different color. Say I use orange. This way, downwards. Can you see? I'm labeling a point C here. So from point B to point C, you're going from y equals 0 to y equals -1. That means that you are traveling towards the left a distance of 1 meter. Let me label the distance of 1 meter. Just now over there was also 1 meter. Oh, I forgot to label one more point, which is the t. T equals 0, t equals pi/2, then this is t equals to pi. At t equals to pi, you go back to origin. Then after that, at t equals 3pi/2, from t equals to pi to t equals 3pi/2, you travel the orange distance here towards the left. Okay, until you hit a point over here. And that is your point C. I forgot to label a point A. I mean point B over there. Okay? Okay so far? And then finally, you travel the final stretch, which is, I'll use a yellow color highlight, from 3pi/2 to 2pi. This amount of time, you travel from -1 meter, you have a -1 meter displacement to 0 meter displacement, which essentially means you go back to the origin. So maybe I will use black color. Sorry, give me a second. Let me reset the app first. I think I need to reset it to make it go faster. Please go away. Why can I not? Okay. Sorry, I need to stop the share screen first. All right. What is going on? Okay, and what was I saying? Okay. Can you see my shared screen?
Yeah.
Yes, okay. Oh, good, it's loading a bit faster. Okay, so anyways, finally you're back at point C, right? And then you have to travel all the way back. Let me color it in yellow highlighter. It's lagging again. Wow. Okay, and then you finally travel back to the origin, point O. Does it make sense? Pink color, red color, orange color, yellow highlight. Okay, so we go from here to here and then finally back there. Yeah, so that is what the S against T, this S equals to sine T diagram is describing. When you translate it into a particle diagram, move left and move right. Okay? Can understand now? Okay, very good. So go back to this procedure. Let V equal to 0 to find T. What they're really trying to do is when you let V equal to 0, you're trying to set ds by dt equal to 0. Okay, V equals to 0 is really just the same as ds by dt equal to 0, which means you're trying to find the TP, stationary point, SP. And where is the stationary point? If you look at the graph of this one, it's really just the maximum point there, minimum point there, right? And maximum and minimum point is really just, if you look at this diagram, this particle diagram, it's just the turning points. This part here where you turn, and that part there where you turn. Can you see? You're sort of turning, you're going from the left, you're going leftwards, and then you suddenly change to moving rightwards. Moving leftwards, change to moving rightwards. Okay?
Okay.
That's why we call it a turning point. You literally turn around. At first, you move from right towards left. Now you move from left towards right. Then you have to turn. Okay? Yeah, good. So first step is to figure out the turning points. Then after that, what you do? Step 2, find S for each of the values of T found in step 1. That's basically asking you to sub the T back into the formula for S, which is very, very similar to the Desta procedure, right? Differentiate equal to 0, solve for T. Then sub the T back in to find the S. Okay? Maybe I'll put down here, similar to Desta. Don't need the TA, don't need the table. Just DES. But you have to sub back in as well. Step 2, okay?
Yeah.
Very good. Move on to step 3. So for step 3, you want to find S for T equal to 0 and T equal to N. That's basically asking for the original position and the final position, because you're traveling for how many seconds? Find the distance traveled in the first n seconds. So T equal to 0 will give you the value of S at the beginning, and T equal to N will give you the value of S at the final position. Now, take note, most of the time when T equal to 0, S is also equal to 0. In other words, S of 0 equals to 0 usually. But in more difficult questions, it's not always the case. Okay, sometimes your particle may be already some distance away from the original reference point. Like, for example, you could have, here's a diagram, here's the origin, then here's a point. This is when t equals to 0. You're already maybe, let's say, 10 meters away, 10 meters in front. And then you start to move around. Hit a turning point, Move. Okay?
Okay.
Yeah, now? Good. Yeah, so from there, what you want to do after you have step 3, figure out all these values of t and their corresponding s value, is to draw the path of the particle on a displacement time graph. Okay, here, honestly, displacement time graph doesn't require you to draw the s against t diagram. Instead, what they're describing is this fellow here. Or this diagram. Maybe I'll just call it a stick diagram. Okay? Draw this snake diagram because it will help you a lot to figure out the distance traveled. Just like this guy, similar to this guy. Right? From the diagram, you can immediately tell the difference between the distance and the displacement, right? Okay, very good. Then now let's go through examples. First one, example 1. A particle moves in a straight line in such a way that t seconds after passing through a fixed point O, its displacement from O is s meters. So given that s equals to 2 minus 4 over t plus 2, find part 1, expressions in terms of t for the velocity and acceleration of the particle. So just for fun, I decided to draw the graph of s equals to 2 minus 4 over t plus 2. Okay, so what you realize is that the graph looks like this, but the only relevant part is when t is more than 0 or equal to 0. So I scratched away those parts that have t that's not more than or equal to 0 using a pink color scratching. Right, so focus only on this right half here. Let's see. Hey, where's my highlighter? This part here, okay? On the right side. Right, so carry on. So now what we have is s equals to 2 minus 4 over t plus 2. You differentiate it to get the v because of the formula s, v, and a. Differentiate, you get 4 over t plus 2 bracket square. Just use chain rule. And then finally for acceleration, you differentiate v. You just get negative 8 over t plus 2 bracket power 3. This part should be okay for you, right? You don't need me to demonstrate, do you?
Okay.
Okay,
Yeah.
right? Good. Now for part 2, the value of t when the velocity of the particle they tell you is 0.25 meter s power negative 1. This is the same as 0.25 meter per second. You know this notation, right?
Yeah.
Yes, okay, good. So what you need to do is to just substitute v equals to 0.25. From there, you solve for t. Simple, right? Good. But just make sure you reject the negative one because t is positive, cannot have negative value. How about part 3 now? Find the acceleration of the particle when it is 1 meters from 0. Here, 1 meters from 0 means what?
Displacement is 1.
Equals 0.
Sorry,
1.
Displacement is 1.
But we don't know the t, right?
Yeah.
Yeah, then from there but we already have a formula for s.
So for t.
From there we can solve for t. Yes, that's exactly what they did. So when s equals to 1, you just sub in into the formula, you get equals to 1. Then from there, blah, 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 you can solve for t. I'm sure you know the algebra, right? So solving for t, what do you do next? You can then sub it back into the formula for a, and you can get the acceleration. Let's see, if you recall, the formula for acceleration above was already found. Negative 8 over 1, t plus 2 bracket power 3. So all you need to do is to copy and paste it here, right? Let me zoom in, and then you substitute in the t equal to 2, and then you get negative 1 over 8. Take note that the negative sign is important here. You don't throw away the negative sign because it will tell you that it is decelerating. Here, take note of the phrasing. They say acceleration is negative. If you drop the negative, you would say the deceleration is 1 over 8 meter per second square. Deceleration blah, 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 is 1/8 meters per second squared. If you don't want to use the negative sign, you have to use the correct English phrase. Otherwise, the more easy way is just always say acceleration, but include the sign. Acceleration, then you include the sign. Is that okay?
Okay.
Can I hear the sign matters, plus and minus, because there's a meaning to it. Slowing down is deceleration, negative sign. Speeding up is positive sign for the positive sign, and you say acceleration. Okay, next example. Let's see. A particle moves in a straight line such that its displacement s meters from a fixed point A is given by s equals to 2t plus 3 sine 2t. So here it's from a fixed point A. It's not O anymore. It's not O, not always O. Where t is the time in seconds after passing point A. Okay. Find part 1, the initial position of the particle. So initial position here means t equals to 0. Position just means you want to figure out the s value. Okay. So you just copy the s formula, sub in t equals 0, you get a 0. So therefore, the particle is initially at point A. So if this happens to be, let's say, a different formula, s equals to 2t plus 3 sine 2t, and then I plus 5. Then if I sub in t equals 0, what will I get? I'll get s of 0 equals to 5, right? Good. Then what does it mean now?
Initially is 5 meters away from the origin.
Positive 5 meters away. So that means that it will look something like, here's point A, then the particle starts here. It's positive 5 meters to the right. This is t equals 0 position. Okay, but that's not the case. So let me just scratch it away. Okay, this is a scenario where the starting point is exactly the same as the reference point. This fixed point is the reference point. Right, good. Moving on, part 2 now. Find the expressions for the velocity and acceleration of a particle in terms of t. Very simple, just differentiate. This one, okay, right?
Okay.
Just differentiate. Reason is SVA. Forward direction, differentiate. Backwards, then you integrate. Okay, next, part 3, the time at which the particle first comes to rest. Comes to rest means what? It's always equal to 0. What is equal to 0?
S is equals to 0. Wait, V is equals to 0.
V equals 0. Rest means you're not moving, so the velocity is 0. S may not be 0. You may be far away, but you stop moving. Like this is point A, but you're far away over here, like 20 meters away, but your V equals 0. Your S equals 20. Okay, so it's not S equals 0, it's V equals 0. Okay. Like the particle could be like this, and then it turns around, and it goes this way. Something like that. Okay. Mic test, can you hear me?
Yep.
Yes, okay, good. That's part 2. No, what was I doing? That was the first half of part 3. So part 3, when a particle first comes to rest, you sub in V equals 0, right? So you just have to take the formula for V here, equate it to 0. Then from there, you can solve for T. That's exactly what they did at the bottom. V equals 0, sub in the formula for V equals 0. Then you just solve for T. Here, they skip a step. When cosine something is negative, first step is to find the alpha first. So so alpha will be cosine inverse of just positive 1/3. Ignore the minus. So you get some decimals. Then from there, you try to solve for the 2t angle. So if it's negative, ASTC tells you which 2 quadrants. Cosine 2t is negative, so which 2 quadrants?
It is the second and third one.
Second and third one. So it must be whatever was the alpha, you take pi minus the alpha, or 2t, you take pi plus the alpha. Okay, here one of them will be rejected. Which one is it? Let's see. Here they are asking for a time when the particle first comes to rest. So that means that you here now you have 2t equals pi minus alpha and pi plus alpha. Which one is the first comes to rest? The smaller or the bigger one? You want the time. You want the time when it first
smaller one.
comes to rest. You need the smaller one, right? First means you want the smaller t. So over here, pi minus alpha or pi plus alpha, which one will be smaller? Minus or plus?
Minus.
Minus, yes. Alpha will be, okay, let's just actually type it in. I don't write alpha, if not you get confused. Let me type this in, cosine inverse 1/3. Make sure my calculator is in degree mode. Sorry, not degree, radian mode. 1.23095. Okay, so this is 1.23095, 1.23095. Pi is just some number 3 point something minus 1 versus pi plus 1. Right? Okay, where's my highlighter? Let me try again. Pi minus away 1 point something, pi plus 1 point something. Which one is smaller? Clearly, this is smaller, right? So that's why we want this guy. Sorry. Wow, every time I change from a highlighter to a pen, I need to wait around like 5 seconds. Very slow. Okay, and then from there you have to divide by 2 to solve for t. So t equals to half times of pi minus 1.23095. Okay, and just type in a calculator, you should get a 0.955. Okay.
Yep.
Very good. Moving on. Example 3, a stone that was initially at rest was thrown from the ground into the air, rising at a velocity of v equals blah, 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 where t is the time taken in seconds. Find the maximum height reached by the stone. So let's just draw a diagram first. Here is the floor. Here's the path of the stone. It goes up and then it goes down again. So let's just pretend now, maybe it doesn't curve. Make it a lot simpler. Just go up first and then it goes back down. Okay, good. So maximum height reached by the stone. When do you get a maximum height?
V equals 0.
V equals 0, right? Maximum height means you want the maximum point of S. So how do you get maximum point of S? Maximum point means you have to follow that star procedure. D, differentiate S. That star, don't need the table lah. Just that. So differentiate the S with respect to T, which is the velocity, and then you equate it to 0, and from there you solve. Right?
Okay.
Right, so you need V equals 0. So maybe it would be a good idea if you just write down this bracket V equal to 0 at the side to remind yourself what you need as equal to 0 at the beginning before you start solving. Right? Then from there you see that you have V already. So that means that you can just actually jump straight to this line. Why did they try to find the S in this case? Was it requested by the question? Okay, this part, I think they're preparing for part 2. They're preparing for part 2. This one not very relevant yet. You can just start from here onwards. At maximum height, V equal to 0. Then they already gave you the formula for V, equate it to 0. From there, solve for T equal to 4. Okay? Can?
Okay.
But, oh, right, I get it. Because at this stage, after you have T equal to 4, you want the corresponding height. So that's when you need to sub the T back into the formula for S. But you don't have the formula for S yet. So that's why this part at the beginning, you try to solve for S. How do you get S from V? How do you get S from V?
Integrate.
Integrate V dt, and then you get your S. Okay? So that's exactly what they did here. Integrate V dt. So integrate 40 minus 10t, you get 40t minus 8. Okay, here let me slow down a little bit. Integrate 40t, then you subtract away integral 10t dt. You can also factor out the 10 here. So you're left with minus 10 times integral of t dt. Integral of t dt is just t squared over 2 minus 10 in front times. Then from there you get 10 and 2 cancel away, you're left with minus 5t squared. Is that okay?
Yeah.
Okay, Very good. And that's how you get the answer here. But not enough, because we also need to solve for C. Here, you can assume that the S equal to 0 because you are thrown from the ground. So S equal to 0 initially, right? So T equal to 0. T equals 0, S equal to 0. From the English words in the phrase. From the English words, you translate to the math. Okay?
Mhm.
Yeah, then from there, sub in T equal to 0, S equal to 0, and you can solve for C, which is equal to 0. Okay? Boxed up the wrong part. Yeah. Here. All right, good. So that is the formula for S. You already have the T. Combine these two, and you will get your answer for S, which is 80. Okay? Is that okay?
Mhm.
Okay, good. Move on to part 2. Find the values of T when the particle is 35 meters above the ground. So above the ground. So here, I think you can safely assume that when you go upwards, then the S will be positive. S will be positive. So here, what they're really asking you to do is to sub S equal 35. Does that make sense? You can't go underground, right? Underground, then you'll be negative displacement, but that's not possible. So yeah, so S equals 35. Okay, that's how you get this condition here. Sub in S equal to 35. What do you get? You just get this equation. From there, it's a quadratic. You solve for T. T equal to 1, T equal to 7. Right? Why would there be two values now? Why would there be two values?
It is how it is. It bounces. No. It bounces.
Ah, no. It's a stone. Stone cannot bounce. No, it's more like this. Here is 35.
On its way up and then on its way down.
Yes, exactly. So over here and over there. This is T equals 1, T equals to 7. So it took around 6 seconds for it to go up and back down to 35 meters. Make sense?
Yeah.
Okay, very good. Okay, the particle is 35 meters above the ground when T equals to 1 and T equals 7. When going up. This one is when you're going down. Okay? Can? Move on. Next example. A particle moves in a straight line so that T seconds after passing through a fixed point O, its velocity v cm per second squared, just per second, is given by v equals to blah, blah, blah. The particle comes to instantaneous rest at the point P. What's instantaneous rest here? Rest. Ignore the instantaneous. Rest means?
It's V is 0.
Very good. V equals 0. Exactly. That's it. Okay, fine. Part 1, the value of T for which the particle is instantaneously at rest. Okay, just now I already answered. So V equals to 0. Just underline the relevant English words and put down the corresponding math expression, V equals 0. Then from there, you just have to sub in V equals 0. You're already given the formula for V, sub in and you can factorize and solve for T. Reject the negative answer. Okay, part 1.
Yeah.
Yeah, then next part 2. Acceleration of the particle at P. You're given V, how do you find A? Differentiate or integrate?
Differentiate.
Yeah, differentiate. S, V, A, forward direction from S to B to A is always differentiate. Or you can think of it like this. The units here is meters per second, and meters per second square. So each time you are essentially dividing by seconds. Why do you divide by seconds? Because what we are doing when we differentiate is we are finding the tangent line, right? Tangent line. Sorry, the gradient of the tangent line. So gradient will be rise over run. If let's say that this was velocity and against time, velocity units is what? Meter per second. or in this case, cm per second. Change it to cm per second. Then over here is seconds. Then rise over run will be what? What units? It will be cm per second divided by second. Does it make sense? The change in the y1 minus y2.
Yeah.
Must be in terms of the y-axis, the variable. Y-axis units. So this one, other guy will be x1 minus x1. Then cm per second over second is really just cm per second.
Square.
Right? So that's why we have to differentiate. In terms of the units, you can understand it that way. Okay, anyway, so now we have v, we just differentiate it. So we end up with 8 minus 16. Then we already found the value of t just now, right? So you just sub in the t and you get your corresponding value of a. Okay?
Okay.
Why do I know I need to sub in t equal to 3?
You know you need to sub in t equals to 3. Why?
Because English comprehension. They asked for acceleration, but they didn't just stop there. They asked for at the point P. At point P, what happens?
At point
the
P,
point
v is 0.
V equals 0, which is exactly the answer from the given condition in part 1. Right? So that means that the t equal to 3 will be relevant to the situation here. So you just have to sub in the t from part 1. Okay, it's because of this part at P. It's just English comprehension. If they say acceleration in terms of t, then you don't have to sub the t. Okay?
Okay.
Let me write this down. If they ask you to find the acceleration in terms of t, then you know you don't need to sub t equals something. Next one, part 3, the distance OP. This is when you need to use your 4-step procedure already. Let's take a look at the 4-step procedure. Let me take a screenshot and bring it down. Okay, let's take a look. Oh no, can you see the 4-step procedure?
Yeah.
Now what's step 1?
Let v equal 0. Find t.
Yes. So we should do that. But here, they didn't do that. Why? Why didn't they do that? Because it was already done in part 1.
Oh.
You see that? So don't need to redo the same thing. Can recycle. So t equal to 3, done. And how about step 2? What does step 2 say?
Find s.
Find s
integrate v.
To get the formula for s first. But you gotta see, what do you do?
Sub in s equals 0, t equals 0.
Where did we get that from? Where did we get that from?
T equals 0. S
equals 0.
is the
t equals 0, s equals 0. Where's that information from? Okay, here, actually, maybe the question not so good. Question not so good. You assume it's equal to 0. Let me write this down. T equals 0, comma, s equals 0. Assume by default. Or maybe it's because of point O, but honestly, the question can be clearer. The question can be clearer. Yeah, question can be clearer. Okay, so anyways, assuming that t equals 0, s equals 0, then from there you can solve for c equal to 0, which means you get a formula for s. But still not done yet. That was only finding s. We need to answer step 2. Find s for each of the values of t found in step 1. We already found t equal to 3 as the only value of t from step 1. Step 1 being part 1's answer. Right? Okay.
Okay.
Then from there, you sub in t equal to 3, you get s equal to 18. So therefore, OP is 18. This one, it's because there isn't a lot of turning points. There isn't a lot of turning points. Okay. So now for so far, let's just do an experiment. When t equals to a value that's more than 0, less than 3, let's say t equal to 1. What's the value of s?
When
4
t
minus
equals 4 minus 1 plus 3, 0.
0.
Yeah. Wait.
Okay.
6.
Wait. No. Yeah. 6. Okay, so so what you realize is that as you increase the value of t, this value is increasing, right? So if we draw a diagram to represent the movement of the particle, you start at point O.
3.
When t equal to 1, you are positive 6, so you're moving towards the right. Moving towards the right. How many? What distance? 6 meters. 6 meters here. This is t equal to 1. And then as you continue all the way until t equals to 3, you move a total positive 18 meters to the right. Is that okay so far?
Okay.
And this happens to be a point P. And point P is what is when the particle is at rest, right? So it's essentially a turning point. Turning point means what? Does it continue moving towards the right?
No.
No, instead it
Turns.
turns on. It turns towards the left. So now you're just gonna turn left. If I can give me 5 seconds. Wow, the lag. Okay, is it showing now? Oh no. Go away. Delete. Okay. Like this. Is that okay?
Okay.
Okay, yeah. So now let's look at the last part of the question. The total distance traveled in the time interval from t equals to 0 to t equals to 4. So maybe this is the part that actually requires the 4-step procedure, because now we have t equals 0 to t equal to 4. What step have we not done yet? One, two, three, four. Just now we found s, and then we substitute t equal to 3, right? To get s equal to 18. That's actually step 2. We found the s for each of the values of t found in step 1. But coincidentally, the t found in step 1 is just a single value t equal to 3, which we have substituted in over here to get our s equals to 18 over there. That's for step 2 only. So now we move on to step 3. Let's take a look at step 3. Step 3 says what? Find
displacement for time 0 and time equals to n.
Yeah. But for time equals 0, coincidentally, while we were trying to get the
0.
initial condition, we already found out. Okay, so half of the work is done. Now we try t equals to n.
N.
What's n? Let's read the question again. Part 4 says total distance traveled in the time interval from t equal to 0 to t equal to 4. So that's the n. Okay, so n equal to 4. T equals 0 to t equal to 4. That's my n. So now I just have to substitute in t equal to 4 s equals to something. 4 times 4 squared minus 4 power 3 plus 3 times 4. What's that value? Let's calculate it.
12.
Oh, is it 12? Let me see. Yes, correct. The 4 cube cancel away. Left with just a 12. Okay, so now that we have all the information, we move on to step.
Draw the path.
Draw the path of the particle on a displacement time graph. I already drew it halfway for you.
It's
Let me show
24.
let me show the nicer version over at the bottom like this. Okay. So this is a summary. It would be a good idea to write down, to summarize all the ideas in a top corner like this. T equals 0, s equals 0. T equals 3, s equals 18. T equals 4, s equals 12. This part here is the turning point. When you set v equal to 0. Set v equals 0. Solve for t sub into S formula, the displacement formula. Okay, so what you realize is it will go towards the right and then it turns. But take note that when t take note that when t equals to what's it 4, right? The s equals to positive 12. So your particle cannot be all the way towards the left. Positive 12 cannot be leftwards. This is the reference point. If it's over here, right, and you label t equal to 4, s equal to 12 here, that's inaccurate. That's inaccurate. Why? Because it's towards the left of the initial point, which means that s will be negative if that was actually true. But no, s is positive 12, so it has to be towards the right. Can you see why it has to be over here? The t equal to 4, this point. Can a bit to the right of the starting point, a bit to the left of the turning point. Sandwich in the middle. But that's because it's 12. 12 is less than 18. And it's positive 12, so it's to the right of the origin. To the right, and it's less than 18. Okay, so anyways, what's the distance here? So this one is a little bit of creative problem solving, but not really. It's this part here and that part there, which I am highlighting, but the screen will take some time to load. Can you see the highlighting? The reddish and the red and purple, orange and purple. Is it showing on the screen? Those are the two distances that you need to find the length of. So for the red part is 18. Let me just highlight the 18. And then for the purple part is 18 minus 12. Can you tell why it's 18 minus 12?
Yep.
Yes, the long minus the short. Okay. Some students struggle to see this part, but let me just label it to be extra clear. This one like primary school model method. I label 18, and here you label 12. So long minus short, that gives you the difference, which is the purple part. Okay. Here now? Okay, very good. Next example, example 5. A particle is moving in a straight line. It passes through a fixed point O with a velocity of 4 meters per second. The acceleration of the particle a meter per second is given by a equals to 2t minus 5, where t is the time after passing 0. Find part 1, the values of t when the particle is instantaneously at rest. Instantaneously at rest, what equal to 0?
V equals 0.
V equals to 0. So do we have V? What's given?
We have acceleration.
A. So we have this. What do we need? We need V. So how do you go from A to V?
Integrate.
Integrate. Okay, the answer is on the left already. That's why. But I hope you get the concept, right?
Minus V.
Yeah, so you integrate this guy, you end up with t squared minus 5t, but don't forget arbitrary constant plus c. Then now you have to sub in initial condition. Right, so over here, they say pass through a fixed point and then velocity of 4. So v equal to 4. This fixed point O is your reference point, that is your t equal to 0. Okay?
Okay.
Yeah, so t equals 0, v equal to 4. That's how you get this condition. Then after that, you can solve for c. I mean, substitute the t equal to 0 and substitute the v equal to 4. Then from there, you can solve c to be 4. Solve for c and you get c equal to 4. All right? Okay. Then from there, sub in c equal to 4, you get a formula for v. So, yeah. How to continue?
Sub inside, solve for c. Then you have sub the quadratic equal to 0. Then you get answer.
Exactly, right? So because of the phrase here, instantaneously at rest means v equal to 0. You have your v here, so you just have to substitute v equal to 0. From there, you can solve. You get t equal to 4, t equal to 1. That's your answer. You cannot reject anything. Both are possible. So why are there two values? Just now I thought only one value. Yeah, you see this one? For
it
this
stops twice.
Stops. What do you mean by stop?
It is at rest 2 times.
Yes, correct. So just now was t equal to 3, it rests only one time at t equal to 3. So in terms of the diagram, look, when t equal to 3, how can you come up with a way to describe this t equal to 3? What's going on with the point, with the particle?
Not moving.
At rest.
Stationary.
Stationary, right? Which is a bit funny, but eventually what happens? What do you call this point? When you move from t equal to 0 to t equal to 3 and then t equal to 4.
Turning
You're
point.
going from turning. Yes, you're turning at that point. Right? So now just now you have only a single t equal to 3 and one single turning point. So now that you have two different values of t, how many turning points?
2.
2 lor, at t equal to 1 and t equal to 4. Okay, so know that at the back of your mind, we carry on and solve the rest of the question. So part 2, find the displacement of the particle when t equals to 2. Displacement is what again?
Displacement.
SVA.
Displacement is S. You have
We have
V.
S.
So you integrate V.
Exactly. So integrate already, you get a arbitrary constant, but don't worry, we have our conditions already.
Sub in
I think we have to assume s equal to 0 as well.
S equals 0, t equals 0. Then you solve for the C. Then after you get the C. Okay.
They use a C subscript 1 to not confuse you between C and C1. Previously already integrate to get a C here. So now they just change the notation to C1. Okay? Right? So anyways, yeah, got it. Yes, just integrate the V, sub in the t equals 0, s equals 0 condition. Oh, by the way, in the future, if you do engineering, they will call it the initial conditions. Okay, initial conditions, t equal to 0, s equal to 0. And from there, you can solve for the constant. It's just an English phrase, doesn't really matter. You know the procedure can already. C equal to 0, good. From there, solve for s. But what we need is displacement when t equal to 2. So sub in t equal to 2 and you get your answer. Right?
Okay.
Okay, good. Yes, challenge, since we already have all the information we need. Can you find out the distance traveled by the particle from, let's say, t equals to 0 to t equal to 5?
T equals.
Rewrite the question first. Find distance traveled.
Just write out.
Yeah, t equals 0 to t equals to 5. Okay, so let's follow the procedure. Let me bring down the procedure again. Copy, scroll down, paste, and resize. Give me a second. Let me, you know what? I should just start a new page. Give me a second to start a new page, add a new page. Maybe over here. Okay. Wrong location. Let me. Okay. Where's the screenshot? It's over here. Paste. Okay, let's read the procedure together. So step 1, let V equal to 0 to find T. Do we have that already? Yes, if you scroll up, we have V equals 0, T equal to 4, T equal to 1. So let's just write down the conclusion. When V equals to 0, T equals to, what is it again? 1, T equals to 4. Okay, step 1 done. Step 2.
Find S for each of the values found in step 1.
So that means we need the formula for S, right? So let me just retrieve it for you. S equals to 1/3 T cubed minus away 5 over 2t squared plus 4t. Right? Good. And from there, we can scroll up. Paste it here. What was it again? Find S for each of the values found in step 1. So when t equals to 1, S equals to 1/3 minus 5 over 2 plus 4. What's this equal to?
This is equals to
11 over 6. Wow. Eh? Don't forget a plus 4. I got the answer already. Huh? 11 over 6. 1 and 5/6. Positive. Can? Okay. Next one, when t equals to? The next turning
when t
point.
equals to 4.
4.
In
So get 1/3 times 4 over 3. You get what's going on, right? Following the procedure. Yeah, okay, good. Let's just quickly do that.
40,
Oh, use our calculator.
40
Use
plus 16 over 3 minus 56.
I got negative 8 over 3.
Yeah, that sounds right.
Okay, yep. The main point is not the mental sums. You need to interpret the diagram. That's the main point. The snake diagram. Okay. Not step 2 is done. Okay, let's go on. Now step 3, find S for t equal to 0 and t equal to n. Now when t equal to 0, this one, sorry, the question for t, by default, you have to assume t equal to 0, s equal to 0 if they never say. They say from a fixed point s, fixed point O, typically t equals 0, s equals 0.
And find when t equals to 5.
5, yes.
So 1/3 get 5 cubed. Then
Plus 4 times 5. So we can calculate that. Everywhere there was a t, you replace with a 5. And we get negative 5 over 6 meters. Maybe I'll just translate this into decimals first. 1 and 5/6 is 1.833 meters, roughly. Negative 2.23 is negative 2.666 meters. This one, negative 5 over 6 is negative 0.8333 meters. Okay so far? Now draw the path. How?
okay. So when t is 1, then it's a turning point. Okay, wait. So first the thing is here.
Good.
When t equals to 0.
Maybe it will be good if I do the following. Wait. Before you continue, I should sort it in ascending order of t, so it's easier to understand. I think it'll be. Oh no! Why is it moving? Okay, wait. Let me sort it in order, like this, and then this guy. Oh, the meters move over. Okay, meters here, and then like this, so that it's easier on your brain when you are drawing the diagram. The last thing you want to do is to work so hard to find all the values already, and then you accidentally read wrongly. Okay? Yeah, so okay, continue. Yes.
So it moves in a straight line. Count.
Why to the right? Why not left?
Positive.
Sorry?
What's positive?
Which one? Which value are you looking at? Positive what?
1.833.
Yes, correct.
So here's t equals 0. Then when t equals 4. It's like over here. So it goes,
Negative 2.6. Oh, no, wrong. You're labeling wrong. The negative 2.66 is the distance from the origin.
origin.
This vertical line all the way to the left. That's the 2.66. Yeah.
Then goes back. Oops.
Yes. So total distance traveled. We need to
3 plus. Okay, this distance times 2.
yes, correct. Because you move from left to right and origin to the right and then right back to the origin. So 2 times of 1.833. Minus. Okay, good. You got it already. Very, very good. Okay, let me copy down your working. Copy for reference. So this is as difficult as it gets already. You have completed. Oh, bless you. Okay, so now that's essentially it for the kinematics topic. You have completed the AMAX syllables. Congratulations.
Can't remember all can't remember the negative sign. Negative sign equal what? Negative cosine.
Wait, what identities are you talking about?
The negative identities.
Oh, negative angle identities.
Yeah.
Just remember, cosine is the one that's misbehaving. Cosine cannot tap out, cannot factor out the negative. Sine and cosine can factor out. Is that what you're talking about?
Yeah, I think so.
Sine, cosine, tangent, negative theta, negative theta, negative theta. Sine, cosine, tangent, theta, theta, theta. What's the relationship? The first two can factor out the negative sign. I mean, the first and third one can, cosine cannot still remain positive.
Okay.
Yeah, that's it. Okay, but let me just try and draw the diagram nicely so you can have a reference. So typically I wouldn't label negative 2.66. I'll just label the distance at the bottom like this. So I will draw a curvy line like this. And then this one drop down. Maybe extend a bit more. If you're an engineer, you must learn how to draw this broken line. Then draw a curvy line like this. Or you draw a double arrow like this to label your distance. This is what? 0.833, right? Yeah. Okay. Good. Then it will be even nicer if you can draw an arrow like this. Arrow, 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 to remind yourself of the movement of the particle. Okay. Can? Yeah. Okay, then good. That's it for this question. Move on. Can you help me to clear the screen? Yeah, good. Okay, next example, example 6. Particle starts at rest from a fixed point O, travels in a straight line so that t seconds after leaving point O on the line, its acceleration, a meter per second square, is given by a equals 2 cos t minus sin t. So sometimes you start to introduce trigo functions. So your differentiation integration must be there already. You need to know how to differentiate integrate. Okay, find part 1, the value of t when the particle first comes to an instantaneous rest. So instantaneous rest means what equals to 0 again?
Equals 0.
What equals to 0?
V equals.
Okay, you see, go back to this table. Okay, everything also equal to 0. So that's not the main point. You should tell me what is equal to 0. T, is it V, or is it S, is it V, or is it A? Sorry?
V.
Well, actually, this diagram very messy. Let me redraw this. I only need to mention the max and min point. There is max, there is min.
Velocity.
Sorry?
Velocity.
Velocity, v equals 0, right? When you have the at rest. This is the main point, actually. This is the one that will appear the most often at rest. And v equals 0. The rest is you can deduce on your own. You can deduce on your own. Maximum displacement. How do you find maximum point? Differentiate equals 0. The derivative equals 0 because of that star procedure. But derivative of displacement is ds by dt equals 0, which is v equals 0. Okay, that's how you get this part here. Right, and similar for the v, similarly for the v, concluding that the a equals to 0. Okay, move on. Next, what we see. What do we see? Let's see. Yeah, continue reading continue solving. So for part 1, the value of t when the particle first comes to an instantaneous rest. So when it comes to rest, v equal to 0. So all you need to do is to find the formula for v first, right? You integrate. Then after that, you have a plus c. So if you have plus c, you have to sub in initial condition. So let's see what's the initial condition. T seconds after leaving. Why do they say t equals 0, v equals 0?
Why do they say t equals 0? Starts at rest from a fixed point 0.
Yes, starts t equals to 0, at rest v equal to 0. Okay, must translate the English into the math. That is the name of the game. Okay, starts means initially t equal to 0. At rest means v equal to 0. So that's how you get your initial conditions. Okay, so after you have t equals 0, v equals 0, substitute in. So we get 0 equals to 2 times the sine of 0 plus the cosine of 0 plus c. Then you can calculate. So 0 equals to 2 times 0 plus cosine 0 is 1 plus c. From there, c equals to -1. So you see, sometimes c is not 0 because cosine 0 is a 1. It's not 0, okay? Cosine 0 is not 0. Warning, warning. Okay? Then from there, solve for c, you get -1. It's not always c equal to 0, c equals 0. Okay, so anyways, now that you have c equal -1, you sub in and you get your formula for v. Are we done? No. Part 1 says what? Value of t. So you're trying to solve for t when v equals to 0. So we are not done yet. Next line. V equals 0. Oh, is it not shown? Oh, I added an extra page. Wait a minute. Okay, so when v equal to 0, recall the function v is 2 sine t plus cos t with a c equals -1. No? Equate it to 0, then you solve for t. Here it requires R formula. Do you recall R formula?
Yes.
So it's R sine theta plus minus alpha or R cos theta plus minus alpha. Depends on which case it is. Here we have a plus sign. You probably want a sine theta plus alpha. Why? Because you can expand this as R bracket sine A cos B plus cos A sine B, where the A is theta, the B is alpha. So from there, maybe it's not theta anymore. It's T. Right? Good. Then from there, you can get rid of this. You can rewrite it as R cos alpha multiplied by sine t plus R sine alpha multiplied by cosine of t. Then you can see the pattern already. Oh, here we got 2 times sine t plus 1 times cosine t. Here we have R cos alpha times sine t plus R sine alpha times cos t. So compare and contrast, this must be 2, this must be 1. Right? So from there, we conclude that R sine alpha equals 1, R cos alpha equals to 2. If I divide the 2, I end up with This is 1, this is 2. If I take
Tangent
1 divided by 2,
tangent
and
alpha equals to half.
yes, then from there alpha equals to tangent inverse of 1/2. Yeah. So that is alpha. We're not done yet because that was only the left hand side. Because there's also the R to be found. So after we solve for
1 square plus 2 square and square root.
yes, okay. So what we have is R square sine square alpha plus R square cos square alpha equals to 1 square plus 2 square. Factor out the R square, you get sine square alpha plus cos square alpha equals 1 square plus 2 square. But this is equals to 1, so it's R square times 1, so it's just R square equals 1 square plus 2 square. Solving, you get R equals to square root 1 square plus 2 square. Okay, done. Found my R, I found my alpha. What do I do? Sub back in. So there is my R, which is square root 5. Sorry, 1 square plus 2 square is 5. So square root 5. Found my R. Alpha, need to key in the calculator. I believe it is whatever they showed there, 0.4636. It is in radians. Let me double check with my own calculator as well. Tangent inverse of 1/2, and I get a yes, indeed, 0.4636. Okay, that's how you get this part here. Oh, they move in one line. They never show the working. I hope you understand this one. Okay, the -1 bring over. That's how you get the positive one. Can our formula?
Yeah.
Very good. So from there, you can solve for t. Just bring the root 5 over 1 over root 5. Then please remember, always find basic angle first. You get the, how do you find the basic angle? You take sine, and then you take the inverse of the right-hand side, but make sure the right-hand side is a positive value. Even if it's negative 1 over root 5, you throw away the minus, and then you take the inverse. Okay? Throw away the minus sign, take sine inverse of the positive version. Okay? And you should get a 0.4636. So from there, because sine of t plus whatever equals to a positive 1 over root 5, positive is in which quadrant? You have to use add sugar to coffee. All science teachers crazy. When is sine positive? Which
First
two quadrants?
quadrant, second quadrant.
1, 2, 3, 4. So 1 and 2. So that means you must be in quadrant 1, which is the basic angle 0.4636 radians, or quadrant 2, which is pi minus. This 2.677 is pi minus away the alpha. Okay. Here is alpha. Okay, maybe just to illustrate this, quadrant 2, this angle is pi minus alpha, where the angle over there is alpha. Okay. It's Q2. Pi minus alpha. But I think you know this already, so I don't talk too much. Yeah, anyways, you have these two angles already. Then from there, solve for t, just bring over. Plus becomes minus 0.4636. You get these two as your answers. T equals 0 and t equals 2.21. Round off to 3SF. So when do you first come to an instantaneous rest? They say t equals 2.21. Why is it not 0? Why not 0? You read the question at the beginning.
0 is
okay, maybe again it's just English comprehension. You say first comes to means must have some progression already, some time must have passed. So it's a value, that's why I'm looking for a t that's not equal to 0. Some time must have passed, so t more than 0. Okay, move towards. Okay. All right, moving on. Any questions? Part 1?
no.
No. Okay, good. Part 2. The distance traveled by the particle in the first 3 seconds after leaving point O. So, first 3 seconds, that means t equals 0. to t goes to 3. That's your n. Do you remember the 4-step procedure?
No.
Okay.
Find turning points.
Yes, find turning points. How do you find turning points?
You find turning points by when v is equal to 0.
Yes. Right.
So
let's start. Yeah, v equals 0. Yes.
So
Then we already did that. Did we not do that? Did we? I can't remember. Wait, let me see again. Yes, we did. We already did that. We found the 2 values. So step 1 is done. What's step 2?
Then find sub both of them into S.
Sub both of them into S. And here you go. They already did that for you. Okay, up to here. Yeah. Okay, but before you can sub into S, you need to find S first. So you realize that we don't have S, so you need to go and integrate first. Then you can find your S. But there's a constant here. They use the letter D. You have to sub in initial condition again. T equals 0, S equals 0. Usually it's by default. T equals 0, S equals 0. From there, solve for D and then sub in. And yes, what you said was correct. Sub in into the S formula and you get 0 and 1.785. Okay, then what else? That was step 2. What's step 3?
Wait, they went from t equals 0 to t equals 3.
Yeah, first 3 seconds, yes.
Alright, then sub t equals to 3 into
sub t equal to 3, right? Okay, good. So sub t equal to 3 into S, and then you get a corresponding value of S equals to, let's see, review 1.121. Ding. Okay.
And drawing.
And draw. Very good. Yes. So this is what happens. T equals 0, S equals 0. So you're on the starting point itself. T goes to 2.214. The S becomes positive 1.785. Positive means that you have to be towards the right. Okay, towards the right. And that's how they get that point there. Good. Then from there, t equal to 3, S equals 1.121. So it's a turning point, so definitely you turn left. But can you turn left all the way until you plot here t equal to 3?
No.
Instead of here, you go all the way left. Go
No.
left, ma? No, man. Why cannot?
Because S is a positive value.
Yeah, the S equals to
positive value.
Positive 1.121, which means that the distance from the origin here to 1.121 here, right? It should be towards the right. It's just the number line. Okay, so I was just playing around. No. Of course not. The 1.121 has to be more than 0, but less than 1.785. So it's somewhere in between over here. Okay. Yeah, then that's how you get this diagram. Not enough. You need total distance traveled. How? Hi.
Use 0 plus, 1.785 plus bracket open 1.785 minus 1.121 bracket close.
Yes, correct. Okay, so it's essentially this yellow and this blue part. Yellow part is 1.785. Blue part is 1.785 minus 1.121. Okay. Okay. Very good. Then we have covered kinematics already. Done. Now it's more and more practice. Okay, we got extra time. I can assign you homework already. Later I will assign you. Maybe now I go back to the ASS.
Okay.
Yeah, have time now. Okay, so question 2. Okay, after I told you you got it already, the factorization, that's fine.
How about I send question 1 on like a different thing?
Question 1 is what?
I send it on like a different thingy, like it's in a different PDF.
Oh, sorry, I didn't mark question 1, is it? Where's the question 1? Oh, could you send me again? Or like reference the message again. Where is it?
It's here.
It's where? Oh, I didn't see it. Oh, sorry. Wait, let me, since I'm already here. This one. Okay, let's see. What's this question one? Let me just double check again. ASS is this guy. Question 1. Okay, a curve is such that d2y by dx squared equals to 2 times 1 minus 2x. Equation of the normal to the curve at the point -1,7 is 9y. Oh, equation of the normal to the curve at the point -1,7 is whatever was given. Find the equation of the curve. Okay, so let's see what you did. d2y by dx squared equals 2 bracket 1 minus 2x. Okay, 9y equals to x plus 64. That's equation of normal. Okay, you make y the subject. That's very good. At a point -1,7. d2y dx squared equals to multiply the 2 into the bracket 2 minus 4x. Good. Integrate, you get 2x minus 2x squared plus c. Good. When x equals -1, y equals when x equals to -1, let me think. The gradient of the normal is 1/9. So that means gradient of the tangent is -9. Good. Reciprocal of positive 1/9. Yes. So sub in dy by dx with -9. Correct idea. Then sub into 1, you end up with -9 equals 2 times x become -1. -2 multiplied by x squared becomes -1 bracket square plus c. That's very good so far. Good. Good. Reciprocal. Good. Okay. Sub in, solve for c. Let me see. Is it -5 minus 2? This one +1 minus 2. There's a -4, bring over +4. 4 minus 9, -5. Good. C go -5. Okay. Then from there, you solve for y, integrate. So integrate 2x, you get x squared. Integrate minus 2x squared, you get -2/3 x cubed. Yes. Integrate -5, you get -5x plus another c. Here maybe, okay, can get away with, it's understood, but maybe it would be better if you use a letter D instead.
Okay.
Yeah, use a letter D. Okay, good. Okay, now I need to clear screen, scroll down. Okay. Then there's a point. It passes through point -1,7. So now you can sub in x with -1 and y with 7. So 7 equals -1 bracket square minus 2/3 times -1 power 3 minus 5 times -1 plus c. So this one, -1 power 3 is -1, minus become plus, so plus 2/3. -1 bracket square. Okay, I need to calculate this a little bit. I need to write it down. This is a 1. This is a plus 2/3. This is a plus 5. There's a plus c. 1 plus 2/3 plus 5 is 6 and 2/3. Minus away from the 7, you get positive 1/3. So c equals positive 1/3. Yes. Okay. Then you get just sub the c back with positive 1/3 and you get your answer. Very, very good. Rewrite it in decreasing order of power. Okay. Perfect. Nothing wrong. Very good. Working all okay. Just the D. Maybe just to be more. This one I'm just being pedantic already. The C and the D, maybe use a different letter. If not,
Okay.
maybe confused. Okay, let me go back to the iPad. Ooh. Okay, let's go to your question paper, which is over where? Here. Okay, question 2 is fine. Question 2, part 3 was, wow, crazy, but you could solve it. Well done. Very, very good. Perfect.
I asked you how.
Oh, did I? I think part 3 I didn't answer you. You did it yourself.
Oh,
yeah. Part 2 was part 2 need to equate to 0 and solve for p equals minus q, not positive q.
lol.
Negative
Yeah,
q. Yeah.
I know. I did p equals to q. Lol.
Yeah, that's why cannot
but it
solve.
still
Right?
worked though. It still worked coincidentally.
It
not work.
I think a lot of times happen where you make 2 mistakes and they sort of cancel off each other. Okay, you got very lucky. I don't know how you managed to do it so many times, but okay. Yeah. 2 different mistakes, they cancel each other off. Acid and base, neutralize. Okay, anyways, here this is a trigo question where the angle is different, theta over 2 and theta. So the moment you see half angle, it means you have to use double angle identity and you use it correctly. Sine 2a is 2 sine a cos a. Yes, good. So now that you have these two factors equal to 0, right? Something multiplied by a second thing equal to 0, it means each of the factors equal to 0. Help me to remember this. A times B equals to 0 implies first feller equals to 0 or the second feller equals to 0. Always this pattern. It's
Okay.
just that the A and the B gets a little bit more complicated. It's cosine theta over 2 on the left. That's the A. And the 7 minus 20 sine theta over 2 on the right. That's your B. So over here, you drew the graph wrongly. Please remember, whenever you have y equals like sine, let's say for example, 2x, you see coefficient 2. That means that from 0 to 2 pi, how many times do you see the full sine curve? Up, down, down, up.
Twice.
2 times. Once and a second time. And they'll scale proportionally. So this here will be pi, right? Then there will be like 4 pieces. Yeah, there'll be 4 pieces. I think you get what I'm saying. 1 piece, second piece, third piece, and then 4th piece. Then you repeat again. Let me just highlight it since I'm already halfway there. Pink, blue, pink, blue, like this. So there will be 1, 2, 3, 4, 5, 6, 7, 8 equal intervals from 0 to 2 pi. Then you just have to take that 2 pi divided by 8 and you get each interval, the length of each interval. But in terms of x coordinate, it has to be, let me see, 2 pi divided by 8 is pi over 4. So here will be 0, followed by a pi over 4. This other guy will be 2 times pi over 4. This other guy will be 3 times pi over 4. And the next one will be 4 times pi over 4. And then the next one is 5 times pi over 4, so on and so forth, all the way. 6, 7, and 8. Can? 6, 7, 8. Okay, you get the idea. But now, here when you have cosine theta over 2, it's really just y equals to cosine of half of theta. I just changed the x to theta. When you have half, how many copies of the full cosine curve down, down, up, up will you get to see from 0 to 2 pi? Half only. Here you interpreted wrongly. You thought it was 2 of them.
Yeah.
It's actually only half. So I drew it for you already ahead of time, like this. Okay, you should only get half of the down, down, up, up. Okay, if you want to extend the other half, it will go until 4 pi. But you don't need it. Okay, this is irrelevant. Okay, so there's only one point of intersection. Only one, what I call a root. One root. Okay. Then from there you can solve. This one will be a pi. Yes, correct. This is pi. So theta equals to pi. Okay. Lagging. Hold on. Yeah, theta equals to pi, right? Okay, then for the other guy, this one is a standard question on how to solve angles, right? Do I need to go through? The standard procedure for solving trigo.
I mean, okay, you move it to one side, then you find basic angle.
Yes, alpha.
See which quadrant. Then, okay, it's this or this. Yeah. Okay. How do you know how many solutions you have?
You can consider adding 360s, right? Or adding 2 pi's to get more answers, right?
Yeah.
You're asking me, well, how do I know when I need to, how many 2 pi's do I need to add? The answer is very simple. You look at the domain here. Guess and check a little bit. Guess and check a little bit.
Domain is this thing. The
domain, sorry. Domain is the allowed values of theta. Allowed values of theta, the input to the function. So sine of something, this is input. Like for example, this is like a machine. It's called the sine theta machine. There's a conveyor belt here. What do you feed it in with? You feed it in with pi over 3 as an angle. What comes out of the machine? Sine pi over 3, which is root 3 over 2. Okay, what goes in and what goes out. Okay, so this is what's known as the input, or the more professional word is pre-image. This guy there is called the image. Then the allowed values are permissible, the allowed ones. Allowed values of inputs. The set of all the allowed values of inputs is known as the domain. Okay, this is a crash course on the function notation and function vocabulary. You don't need to know for Amex. Sorry, I used the wrong word. I cannot say domain. I have to say allowed values of theta, because you are not supposed to learn this yet. Haven't learned yet. That's H2 max.
Okay.
Okay, can allowed values of theta. Don't say domain. Anyways, so yeah, you plus 2 pi. If you just try, Okay, you have to do it yourself. If you go and add on a 2 pi at the beginning before you get times 2, after you times 2, it becomes a plus 4 pi, which definitely goes out of the interval 0 to 2 pi.
Okay.
Right? If you subtract 2 pi, then you end up, after you multiply by 2, it becomes subtract 4 pi. Maybe there's a chance it's inside, but I believe it isn't. There's only 2 of it. The answer to your question is guess and check until it satisfies the condition required. But the rule of thumb, when the coefficient is not half, I have one rule of thumb, which is that if your angle is in between 0 to 2, if your angle is in between 0 to 2 pi, you're trying to solve for like sine, let's say 3x. Let's make it more dramatic. 7x equals to 1/2. How many answers are there?
7.
No, 7 times 2.
14.
There'll be 14 answers. Okay. Why?
Okay.
Because this is positive, then ASTC, you will be quadrant 1, quadrant 2 angle. That's your 7x. So 7x equals to your alpha, and 7x equals to your pi minus alpha. But guaranteed, if it is 0 to 2 pi and the coefficient is a positive whole number, 7x, you will have 14 answers. So here you only got 2 answers. After, actually, it's not the answer yet. You have to divide by 7 and you get the answer. So you actually need how many more pairs? 6 more pairs. So how do you get the 6 more pairs? You add multiples of 2 pi. So you also have to consider 7x equals alpha plus 2 pi times 1. 7x equals to alpha plus whatever is the alpha, sine inverse of half. I think it's the 30 degrees or pi over 6. And alpha plus 2 pi times 2, and then so on all the way until alpha plus 2 pi times 6 to get the 7th pair.
Okay.
And then you divide by 7. Okay, add the 2 pi or 360 degrees before you divide. That's my rule that I always teach you, but you never follow. You always just divide first, then you add. Okay lah, if it works, can now. But the rule of thumb I like to follow is add before you divide. Okay, add the multiples of 2 pi before you divide. Okay, that's just that's only for one specific case. So if it's 0 to 2 pi, inclusive for both, and the coefficient of x over here is a positive whole number. Okay, when it's a fraction, I'm not sure. This one maybe you divide by 2 instead. So just try, and you will see what fits inside the allowed values of theta. Okay. Yes. Next one. Here algebra mistake. Oh no, what happened? I don't understand. How did you manage to get the right answer?
I did. I managed to get the right answer.
You got a half. I don't know how. Here there was a lot of algebra mistakes. You see, tangent x over cosine x is actually what? If you look carefully, it's sine x over cosine x, that's tangent, divided by cosine x. You multiply top and bottom by cosine x, so sine x over cos x times cos x, cos cancel away, left with sine x. Cos x times cos x gives you cos square x. How can it be just sine? Just
I know
sine?
why. Because I did the same thing here also. Wait, no. I mean the two tangent x secant x. Because it's the same thing. So I made the same mistake on the top and the bottom.
Oh, yes. Okay.
So then it still becomes half.
Okay, but then there's another mistake. Okay. Oh, I didn't circle this part. Okay, there is. Where's my pen? There's another mistake, a blue color one. You see, 1 over cos square plus. Okay, got 10 square plus 2.
Because the cosine square times 1 gives cosine. Then cosine square times 1 over cosine give 1.
Oh, sorry. Oh, you swapped the order around. Sorry, I didn't see that.
Yeah, I remember the thing.
Right. Oh, no. I saw it wrongly. Okay. Okay, wait. I gotta. Oh, okay. I get it now. Right. Sorry. I didn't see that. Oh, you swapped the order. Okay. Is it showing? The highlighter. Okay, so I'm not sure how you managed to do it. Let's try it from the start, huh? This one.
Wait, isn't this my only mistake?
But how can you continue if?
Because this thing and this thing is like the same thing. And then I made it. I made the same mistake.
Okay, this is supposed to. Let me use a different color. This is supposed to be sine x over cos square.
X, and then
this guy is sine x over cos square. 2 sine x over cos square x. All right. Okay, then you multiply by cos square. This cos square here and a cos and this fraction there. Multiply into each of them.
Square.
You should get sine x.
I mean sine.
Yeah, sine x plus 1, right?
Plus
That can be a
1
cos square.
over.
Then cos square times tangent square is okay. Cos square times 2 sine x over cos square should be a 2 sine x, so don't have a cos square here. Cos square times 1 over cos square gives you a positive 1 there. Then cos square times 1 gives you cos square there. Okay. Then how to salvage this one? No cosine square. No cos square. Sine square over cos square is tangent square. Okay. And let me see. Cos square can cancel away. I'll have if sine square plus 2 sine x shouldn't have a cos square here. Plus. Hey, how come got a 2 here? Oh, 1 replaced with sine square plus cos square. Right. Okay. Then this part also shouldn't have cos square. Then sine x plus sine square x plus cos square.
Yeah.
Right.
Can still bring out.
And then what just happened? How did you get the right answer?
Is ignore this and then ignore this. And it's still the same. Wait.
Oh.
Yeah.
Wow. Okay.
Technically, my thing is still equal. Technically, it's still equal to half.
I guess so. Yeah, you can cancel. But the reasoning in between is wrong. Okay. Interesting. Don't know. Okay. Very interesting. You managed to find a mistake. You made a mistake, but that led to the same conclusion. Interesting. Okay, but just don't do that.
Okay.
All right. Back to the next one. Question 4. This is the case one where you have a variable power n. Okay. So what you're supposed to do is know the factors here. N choose 0, n choose 1, n choose 2, n choose 3. Are you familiar with this?
Yeah.
Can, right? Okay, then I don't elaborate. Here I gave you a crash course in permutations and combinations. The basic idea here is you got 3 t-shirts, and then you have a bag that has 2 spaces, space for 2 shirts. Now, how many ways are there to put 3 shirts inside 2 shirts? In a bag that has 2 spaces. Here's how you think about it. You have 3 options to choose from. You want to choose 2 of them to be placed in the bag. 3, choose 2 means that you're gonna be writing down literally 3C2 on the calculator, which is 3 times 2 over 2 factorial. Why? Why 3 times 2 over 2 factorial? First box, how many options? 3 options. Second space, first space in the back, 3 options. Second space in the back, how many more options?
2
options. Is it 3 plus 2 or 3 times 2?
times,
right? But here, I listed down for you the 3 times 2 options already. It's 1, 2, 2, 1, 1, 3, 3, 1, or 2, 3, 3, 2, where the 1, 2, 1, 2, and 3 refer to the index number of the shirts. You realize that there's only 3 unique ways. Why? Because each time you select like 1, 2, you're also considering 2, 1 in this 3 times 2. It's also inclusive of the ordering of the 1, 2, and the 2, 1, which means you're over counting. Okay, this is a messy person. He doesn't care about the order you put the shirts inside the bag. So 1, 2, and 2, 1 to him is the same. So how many unique ways are there? How many what I call combinations, unique combinations? It's actually just 3 times 2, but divide by 2 factorial. 2 factorial here is the number of ways to arrange the 2 shirts. Okay? Make sense? Yeah. Okay, that was a crash course. Maybe I should just add it into a new page. Hold on a second. I'll send you the updated file later. This, I think, will be useful in the future for you. PNC, crash course. Okay, next. Anyways, how do you deal with this question? You need what? Descending powers of x, right? So what you see is there are 2 ways to expand this. You either start with the 2 over x power 6 like this, then raise to the power of n, and the other guy raise power 0, correct? And n choose 0.
Yeah.
Last, n choose 1, the other guy 2 over x power 6 power, drop the power by 1, add the power by 1. Make sure the power adds up to n. Right? N plus 0, n. N minus 1 plus 1?
N.
Okay, then the next one must be n minus 2 and 2. Still n when you pick the sum. But this way is not correct. Why? Because the power is increasing. Take note that the n is a positive number. N is more than 0. Just quickly check. Let's see. If we expand this, n choose 0 is 1. This is 2 power n times x power negative 6 to the power of n, so negative 6n. Is this too fast?
No.
Can follow?
Yes.
Okay, good. Then times x to the power of, I think this one power 0, just times 1. Don't need to write.
1.
Next one is n choose 1 is n. N choose 1 is n. Okay. Then this is 2 power n minus 1. This is x power negative 6 bracket n minus 1. Then times x power 5. Combined together, you get x power minus 6n plus 6 plus 5, which is x power minus 6n plus 11. So now let's compare. From minus 6n to minus 6n plus 11, is it increasing or decreasing? The answer is increasing. Is that what they want?
No, they want the other way. Then
so you have to, so you go the other way. So instead of starting with 2 over x power 6 power n, you go with x power 5 power n. Okay?
How, wait, you start instead of x.
Compare. Okay, I box it up for you. First term, second,
you do this. Okay.
first term, second, third. Just go the other way around.
Other way.
Okay. Then from there you simplify. So what you have is 1 times. Okay. I'll pause here for 10 seconds. You read it on your own. Let me know if it doesn't make sense.
Okay. Yeah, it makes sense. They just want the first 3 terms.
Yeah, exactly. So that's why I crossed out the 4th one to remind you, you only need the first 3 terms. Then the rest is simplifying. I wrote there DIY, do it yourself. I think I've given you enough hints. Yeah, it's just simplifying. Okay.
Like, as in,
Should we just do it now? I think we should do it now, because if not, the other parts cannot solve. Do it together. Yes.
wait, this can be made simpler.
You need to combine the x together. X
The
power
x.
12 at the bottom can go up, so x power negative 12.
Oh, like
And then
4x negative 12.
Yeah, then must scratch off the bottom. Then you have x times something, x power 5n minus 10 times x power negative 12. Same base, x different power. Multiply, need to add the power. Yes, so it becomes minus
5.
22.
Okay, x 5n minus 22. I mean, x to the power 5n minus 22. And there's also a 4 here, which cancels the 2. So there's a 2 bracket. And can this be made simpler?
No, I think it's quite simple already. If you want, you can factor out the n from n squared minus n, but not necessary. The main point is you want to convert into a single base x with a power. Okay. And the other guy, let's see, this one will become 2n. Then you have x power 5n minus 5. X power 6 go up, become x power negative 6. So 5n minus 5 minus 6, which becomes minus 11. Yeah.
Then
okay.
This 3.
Yeah. That's it.
What if you just left it like this?
No. You need to simplify. You need to simplify.
Okay.
Yeah. Okay. Moving on.
Oh yeah,
so
they say write down and simplify.
Yeah, and simplify. Yes. When the third term of the let's move on to the next part already. When the third term of the expansion is divided by the second term, you get 8 over x power 11. Show that n equals to 9. So
third term divided by second term. Then you get x.
n squared minus n can factor.
N squared minus L can bring out an n.
Yeah.
2n, n minus 1. Okay. Oh, you can cancel the 2n.
Yes.
N minus 1. So instead of this and this, just n minus 1. Okay. Okay. Yep. Then you bring over x.
No. Simplify the x on one side.
5. Cancel off 5n.
No. Just I think it's safer if you bring it out first. So what you see is n minus 1 is the coefficient multiplied by the numerator x power 5n minus 22. Then this part that I just put bracket and point upwards, what you're doing is you're multiplying a negative 1 to the power. You see? When you bring up, you multiply negative 1. You switch sides, multiply a negative 1. Negative power give you fractions. Here you start with a fraction, you bring up no more fraction, but must times a negative 1.
Okay.
Right. Then it's equal to what was it again? 8x power minus 11. And from there you just need to
Okay. Yeah, okay. N minus 8, then n equal 9 should.
Yes. Okay, you're gonna do the rest on your own. Yeah, you got it already. Okay, good. Next. Go. Part 3. Using the value of n found in part 2, n equals to 9. I give you the hint, TR plus 1. Without expanding this, n is now 9, so just replace with a 9. Show that there's no constant term.
Show that there's no constant term. So n equals to 0.
Huh? Constant
Wait,
term means no,
wait,
no,
r
no.
equals 0.
TR plus 1. Oh, no, no, no.
Wait.
Find the TR plus 1 first.
TR plus 1, isn't that n choose r? Then first term, the power of n, then second term,
Are you sure it's
the
n?
n minus r.
Much better.
Then to the power of r. Wait,
Very, very good.
okay. Then n is 9. Right? N is 9. 9. Okay, then show that there's no constant term.
What do you mean? What? Okay. When it's a constant, what it means is you have, like, for example,
X to the power of 0. I know, and you're
yes,
solving for the x to the power of 0, but I forget what do you have to equate to 0 to find, like, it's like
power,
something r,
the power, not r, the power of x.
the power.
Because a constant, you see over here, 3x squared plus x plus 5, it's an invisible x power 0. There's an invisible x power 0 attached to the 5. Anything power 0 equal to 1.
Oh,
so
wait,
here,
wait. Is
we
it
need
like
the power of x to be 0.
Is it
But how do you?
like 40 minus 5r minus 6r equals 0?
Yes, correct. Yes.
Really?
Yeah, so what you're trying to do is to combine all the x's into one single x and a single power. Then that power you equate to 0, which you have found. Yes, it's 45 minus 5r minus.
Okay, so r
And then you
equals
see a fraction.
45 over 11. Oh, so basically you know it's not possible already.
Yeah, correct. You can only have
Because-
r to be positive integers.
Oh, okay.
Right, r is an index, right? 0, 1, 2, 3, 4 until n. Okay.
Then what's the I thought last time I thought last time it's just like, I don't know. Okay, I look at the last time one. The previous paper.
I think it's because previously the second term here was just a constant. So it
there's
didn't
no
contribute
x.
to the
There's no x.
This is not just a constant. So that means that now this is a more complicated question where there are x coming from both the a and the b. A plus b bracket power n.
Okay.
The b here also has some variable x to contribute. So you need to do a bit more work. Okay? No record. Okay, you go fill in on your own.
Okay.
X power something, you want this guy equate to 0. Okay, good. And show r is not this guy. What's this? R is not a positive integer. It's a fraction. This is a funny notation for saying r is not a positive integer. It's not in the family of positive integers. A set. Okay. Can move on. Notation not so important. Okay, this is very good. Yes, you managed to think of divide by 2 to the power of k. Then you manage to do a substitution, x equals to 3 over 2 power k. From there, you get quadratic, solve for x. And then substitute back with 3 over 2 power k, solve for k. Nothing to say. This one, not so good. There was a serious mistake here. A squared minus b power 4 power half. You go and times half to the power for each of them. No. Cannot. No.
How?
Just a quick example. Let's say you have square root of 5 squared minus 4 squared. Is it the same as square root of 5 squared minus square root of 4 squared?
25 minus 16.
which is 9.
You get 3.
3.
Okay, it's not the same.
Yeah, it's not the same. This is definitely wrong. This is correct. This is wrong. Cannot distribute. So that's why error carried forward. Everything else is wrong.
Okay.
So here's how you do it. What you
Wait,
need
but
to
didn't I get the correct answer? I did. I got the correct answer.
I have no idea how you managed to do that.
No, because I did it twice. No, I did it twice.
Yeah, but it's wrong. The logic is wrong. Yeah, you're supposed to, Yeah, the logic is wrong. No, you got lucky.
Okay.
Lucky 2 times. Wow, very interesting. But yeah, you see, you got this part here with an extra a plus b squared power half, right? But this my answer is, I should be correct, hopefully. It's supposed to be this one, a minus b squared over square root a plus b. Okay. Yeah, let me show you how I did it. Okay, so over here, first thing is a squared minus b power 4. You can factorize it. Let me show the working here. A squared minus b power 4. You can rewrite it as a squared minus b squared squared. Something square minus something square is a plus b, a minus b. But okay, better stop saying a and b. X plus y times x minus y. X squared minus y squared. Right. Then from there, don't forget there's a power half, which is a square root. So square root, you can't do anything when it's a minus sign between. You can only do something when it becomes a product. So here, I decided to split it up into square root of each of the 2 guys, but square root is the same as power half. So I get these 2. A plus b squared power half, a minus b squared power half. Okay so far?
Okay.
Then you substitute in. So here, substitute in already. Anything to cancel? Yes. A minus b squared power something, a minus b squared power something. The yellow color highlights. 3 over 2 power and half power. They cancel away, left with 2 over 2, which is just 1. Right, that's the pink one. Then the blue one, they can cancel away entirely. A plus b squared power half.
Okay.
Then you're left with this one. Then you rationalize with root a minus b. So on and so forth. Then you eventually get the answer. Can?
Wait.
No. Multiply top and bottom by root a minus b.
Okay. Yeah.
You have root a squared minus b squared, which is a minus b squared. But here, coincidentally, there's already a minus b squared. To the power of 2 over 2 is the same as power 1. So I just copy down a few times. Then eventually I drop the power 1. But there's a factor that cancels away entirely, a minus b squared. You can think of this as bracket power, bracket times 1. Okay, so they cancel away the purple color factor. And I have root a minus b over 1. Okay, which is root a minus b. So 1 times root a plus negative 1 times of b. I don't know how you managed to get the right answer. Yeah, no idea. But okay, very cool, interesting. Maybe it's a math research topic you can discover in the future. What's the relationship between these 2? How come 2 different ways can lead to the same answer? What's the pattern? Math discovery. Don't know.
It's a coincidence.
Maybe there's a fundamental, deeper pattern. Maybe all mistakes made will lead up to the same answer. I have no idea. Okay, I'm just talking nonsense. Okay, but yeah, partial fractions topic. Okay, very good. Nothing to say. When you see improper. Oh, by the way, x squared over x squared plus 1. Is this proper or improper?
This is improper.
Very good. Okay, well done. Please remember this.
Yes.
It's improper. Why? Because degree is equal. Definition of proper fraction is degree of the numerator strictly less than degree of the denominator. Okay, strictly. Equal degree here is power 2. Highest power is the degree. Maybe I should write that down in case you forget. Degree means highest power. even though it's equal, it still doesn't satisfy definition of proper. So it falls into the other category, improper fraction. Improper fraction need to do long division. Very good, you can remember. Okay, nothing to say, move on. Part 2, differentiation, easy. Integration, just realize that this other half here, you can make use of the answer from the previous part. Okay, so 7/2 ln x squared plus 1. Very good. Okay.
Okay.
Oh, by the way, let me teach you a new rule. Since we're already here.
Okay.
Integral of f prime of x over f of x dx equals to the ln of modulus f of x. This is not in Amex, but this is the main conclusion that we are getting from here to here. Can you see why? The answer is very simple. Why is this true? Why is integration true? It all boils back down to differentiate the right side, get back the integrand in the middle. Because integration and differentiation is reverse process. If you can differentiate, it means you can also integrate. So let's try to differentiate this ln of modulus fx. What do we get? Modulus is there to make sure it's positive. If not, logarithm of negative number will give you math error. Okay, so differentiate ln, what do you get? You get 1 over f of x. But times chain rule tells you need to differentiate the inner.
Okay.
Then there you go, f prime. You can rewrite this as f prime on top and fx below. Let's just drop the modulus sign now to make my life easier. Can?
Okay.
Yeah, that's just a new identity. It's actually in H2 Max, but don't need to know for now. You'll learn this eventually in engineering Max. Okay, that's for this first worksheet, right? There's another question 7 onwards.
Yeah, a lot more that I don't know.
Yeah. Okay. Hey, actually, let's just zoom down to the bottom one since this is you already learned how to do this. Kinematics, right? Now you've learned already. Okay. A particle moves in a straight. Particle moves in straight line t seconds after passing a fixed point O. Its velocity is given by this guy. Find expression in terms of t for displacement of particle. Okay, this one's very good. Nothing to say. Actually, one more point. Incomplete. Fixed point O means that t equals 0, s equals 0. So from there, sub t equals 0, s equals 0, you end up with 0 equals 0 minus 0 plus 0 plus c, and therefore c equals 0. So s just equals to this guy, 2/3 t cubed minus 8t squared plus 30t plus 0. Sorry for the handwriting, hope you can see. And yeah, then part 2, let's sketch the velocity against time graph and hence find the range of times when the particle is traveling towards O. Whoa, what does it mean? Never seen before. Okay, so what we need now is velocity time graph. This one can draw, right? Because we have the function itself. It's just a quadratic curve. Okay, can factorize as 2 bracket t squared minus 8t plus 15. Can we, what are the roots here? Let me see. 1 minus 8 and 15, I get 5 and 3. Okay, I should have done this. I can do this manually, but calculator is faster. So anyways, we get this. 2 times t minus 3, t minus 5. So v equals to 2 times t minus 3, t minus 5. Now we sketch the curve. Happy or sad face?
Happy.
Happy face. Do we need the negative values of t?
No.
Because time cannot be negative, right? So can just ignore this part. Then let's just plot the point. There must be a root 3 and 5. Happy face. Then what's the y coordinate here? Here, I mean the y-intercept. If you sub in t equals 0, you realize it's just a constant here plus 30. Can you see? 0 minus 0 plus 30. So v equals 30. So it's over there. Lagging. Okay, good. So now that we have velocity against time, what happens when it's above the x-axis? The values of v is positive, right? What happens when it's below? The values of v is negative. Right? Then on the top is positive. So what does it mean when you have positive v?
It means you're traveling in the positive direction.
Yes, correct. Usually rightwards. What happens when v is now negative? You're traveling
It's
in the
going in the other direction.
other direction, typically leftwards. Not always. Okay, so sketch the velocity time graph. Let's read the question first. Sketch the velocity time graph and hence find the range of times when the particle is traveling towards O.
Is this
Yes.
what it means?
Yes, that's it.
Lol. Okay. Hey, actually, is it
actually? Oh, sorry. Towards
What?
O. Let me think a bit.
O
Let me
is
think
the
a bit.
origin. So I thought like plus is like going this way. Then I thought like negative is going this way.
Sorry, say again.
Oh, cause like it says traveling towards O. Then I thought O is like the origin. So you're like moving away at first. And then after that you're going towards it.
Actually, sorry, maybe it's not so let me think a bit about this. S is currently 2/3 t cubed minus 8t squared plus 30t. When it's positive, you're moving towards the right. When it's 0, you're at a turning point. When it's negative, you're moving towards the left. And when it's 0, you're at a when you are 0, you are at a turning point again, and then you move towards the right. You know what? Maybe I think it's better if we just draw the snake diagram. Follow the 4-step procedure. Find the distance. I think it's clearer. Okay, let's do that. So 4-step procedure. Step 1. Sub v equal to 0. What do we get? 2 times this equal to 0. We already solved it. It's just t equals to 3, t equal to 5. Step 2, what do? Sub in these t values into S. Right? But do we have S? Yes, we do. We already found it over here. Okay, let me just copy and paste it here for reference. Oh, sorry. It's 11. Okay. So now you just sub in t equal to 3. You end up with S equals to 2 over 3 times 3 power 3 minus 8 times 3 square plus 30 times 3. Can you help me to type in the calculator while I write down t equal to 5?
Okay. I get 36.
36 for t equals to 3, is it?
Yeah.
Okay, the other guy I also typed in already is 33.333. Okay. Okay, good. What's next? Step 3. They want, okay, step 3 typically is distance traveled from t equal to 0 to t equal to 10 seconds. And
wait, I just realized if you sub in t equals 0, then you get 30.
Right, it's 30. Hold on. Is it 30? No. How can it be 30?
Wait, 0. Wait, it's 0.
It's 0. Yeah. 0. Okay, now, you know what? There is no step 3. We just skip the step 3 down, go to step 4. So plot a few points. S equal to 0, t equals 0, s equals 0. Good.
And here is t equals to 3. T equals to 3. 36. Then will be here.
Move back to 33. Okay.
Yeah, from t equals 3 to t equals 5. Is moving towards.
Maybe we try another point after t equals 5, t equals 7. Let's see what happens.
I get 140 over 3, which is 46.666. So then you move back this way. Move back this way.
So that means from t equal to 5, you turn which direction?
Away from origin.
Okay. So I think maybe it's, in the first 7 seconds, right? Oh, that was part 3. Okay, let's just draw the diagram nicely. Yeah. So t equal to 3, you travel here. Then after that, t equal to, let me think. Equal, no, chef. Kept it. Okay, t equal to 3, go here. Then after that, you turn, t equal to 5, you go somewhere here. Then after that, you turn, t equals to 7, you're somewhere there. Let me just check the values again. T equals 0, s equals 0. Okay. T equals to 3, s equals to 36 meters. Next one is t equals to 5, s equals to 33.33. So it's that distance there, 33.33 meters. Yep. Okay. Maybe let me just bring it down a bit so it looks a bit nicer. Right. And then t equals to 7 becomes s equals 46.6. So from here to here. 46.6 meters. Right, so let's using this diagram we can answer the question properly. Sketch the velocity time graph and hence find the range of times when the particle is traveling towards O. So I think from this diagram you can tell towards O is only this direction, right? Which is 3 to 5. Okay, yeah, your answer was correct. Good. Equal. Okay, moving on. Now we can also calculate the total distance traveled by the particle in the first 7 seconds, not displacement. Okay, so basically find yellow, blue, and green. What is yellow?
36.
What is blue?
36 minus 33.33.
What is green?
46.666 minus 33.33. I mean.
Correct.
Oh yeah.
You could take the blue distance and then you add on, actually 46.66 minus 36. It's the same thing. Okay. Then that's your distance. Okay. Okay. Clearer now? Okay. Hopefully. Hope it was clear. Yeah. Draw the diagram, the snake diagram. I call this a snake diagram. You're just sneaking around left, right. And you can highlight the relevant parts and find the distance. Okay. Let's go back. Any other? Okay, let's go from the top. Okay, this one, something is wrong over here when you compare coefficients. Take note, you cannot always compare coefficients any way you like. Over here, you got equation 1 and equation 2, they are both correct. But can you compare coefficients straight away? The answer is a no. Yeah, so it's a no. Let's pretend that P, you will found the answer is, let's pretend that you know the answer for P is 1. For example, it's not actually 1.
It doesn't work. It doesn't work.
You just try sub in P equal to 1, what do you get? 3P squared is?
3.
3, right? So it becomes 3y squared. Okay, assume that the answer is P equal to 1 first, ignoring your working. Assume P equals to 1, then 3P squared becomes 3. So you get 3y squared. Now you're telling me 3y squared is the same as 1y squared. Therefore, 1 equals to 3 by comparing coefficients. Does that make sense? 1y squared, 3y squared, then you say 1 equals to 3. Does that make sense?
No,
right? Cannot be, right? So the solution, if you want to compare, is to make y squared a subject, or what I like to call the capital Y, right? The vertical axis usually call it capital Y, and that one capital X. Okay, so let me show you the working. what I did is I did a bit more manipulation. I made y squared the subject over here. Okay. Eventually, I will leave you to work it out on your own. Y squared equal to q squared over 3p squared times x squared plus a negative q squared over 3. And then I did a substitution. Capital Y equals mx plus c. Can you see? Then from there, we already know the gradient, right? 1 over 15 can sub in. We also know it passes through 25, 1, so we can sub in 25, 1. Then from there, you just have an unknown c. From there, you just have an unknown negative q squared over 3. Right? I did the substitution over here. Okay? And then from there, you can solve for q. Q equals to plus minus root 2. I'll leave you to check the working on your own. And after you got the q, you do something similar to solve for the p. Because what we have now is, if you compare this part here, q squared over 3p squared is your gradient m, which is 1 over 15. And we already solved for q, which is plus minus square root 2. Just sub in q with plus minus square root 2, 2 separate cases, and then solve for p. Okay?
Okay.
I show the working over here. I'll leave you to read it on your own. Let me
Okay.
know if you don't understand. Another way, if you want to really compare, is to divide by 3p squared over. Then you can compare. But that method will be exactly the same as what I just explained. Right? Over here, made it as 1 y squared. Okay. Yeah, but this is the standard strategy. Convert into capital Y, capital X. Then capital Y equal M capital X plus C. Then you just start comparing the M and the C. Is that okay?
Yeah.
And okay, next. This one, value of x and y equal square root 2 over 5. I'll leave you to do it yourself. Part B now. Determine showing your working if it's possible for any line that passes through the point 2, 1 to be a tangent to the circle with equation, blah, blah, blah. First thing is to realize that this has no link to the previous part A at all. So you're supposed to sketch curve how. Okay. Complete the square. Oh, complete the square. Okay. Get square. The other guy also add on the same thing. Y square plus AY plus. Factorize straight away as well. The other guy is 3, right? Y minus x minus 3. This one.
9, 16, 25, 25, 36. 36, so therefore radius 6.
Maybe you rewrite it as 6 square. Equal 6 square. 36 equals 6 square. Yeah. Then it's clearer. Okay.
Determine
center.
Center is 3 minus 4.
Okay. So center is 3, negative 4. And the radius equals to 6. Then what do you have to do when you got circle?
I don't understand the question though.
Okay, draw the circle first. Draw the circle first.
Okay. Okay.
Clear.
3 minus 4. Center is like here. Then whether it touches or crosses the y-axis and x-axis. I don't know.
Then the solution is whenever you got a circle, you got a center, you can figure out the top, the left, the bottom, and the right points. These 4 points.
Top is just
Let's calculate it over here first. This is 3, negative 4. So plus 6, this becomes 3, 2, 3, negative 10. Right?
Okay.
Y coordinate plus 6 minus 6. Then now it's negative 4 for the y, negative 4 for the y, What happened to your x? Plus 6, minus 6. So 9 and minus 3. And then from there you can tell.
So it does.
Yeah, it will cut. Then now where's my 2, 1?
2, 1. Okay, I mean, it will be like here.
Okay, good. How do you know whether it is inside the circle or outside the circle?
It's definitely inside.
Or is it on the circumference itself? Remember
No,
we went through this.
Calculate distance from the point 2, 1 to 3, -4.
Yes, the distance to
It's
the
less
reference
than
point.
6.
Actually, oh, is it? Wait, actually, I haven't calculated yet. Let me see. 3 minus 2 bracket square plus 1 minus -4 bracket square. Take a square root of 26. I get 5.099, which is less than radius 6. Yes, okay. Maybe I write down distance between 2, 1 and the center 3, -4 is square root 26, which is approximately 5.099, which is less than 6. So therefore it's inside. Your diagram is perfect. Very good. Then now let's read the question. Determine, showing you're working, if it is possible for any line that passes through the point 2, 1 to be a tangent to the circle.
Yeah, I don't know what that means.
What does it mean for you to be a tangent to the circle?
Like it touches the circle circumference.
So now they are saying that if you have a line that passes through this point, okay, so where's your point? Let me sorry. Okay, here. You have a point here, right? You have a line, you have a line, you have a line, you have a line, all these possible lines. Can they ever be a tangent to the circle?
I mean, they will touch the circumference.
But tangents, how do they look? Okay, let me remove.
Yeah, but that's not what you mean. You mean like this, right? Or like,
yes.
I mean,
so what you notice is that
Oh.
tangents to the circle must always be outside the circle. So the answer is not possible.
but if so, you're telling me if the point is outside the circle, it can be.
Can it? Maybe, yeah, can. I mean,
But can't it also like not be?
but the question is not asking about that. Yes, you're correct. It could be and it couldn't be. That's possible.
Oh, okay, okay.
Actually, no. It will always be possible because of tangents from external point. Ice cream cone theorem. It will always be possible. Yeah. But the question is not asking about external points. They're asking about interior points. That 2, 1 is inside the circle. It's not on the circumference. It's not outside. It's inside. And in that case, it's impossible for you to construct a line that passes through the 2, 1 and also be a tangent line at the same time. Is that okay? Ken? Yeah.
Okay,
so maybe you can just say 2, 1 inside cannot have line which both passes through 2, 1 and is tangential to circumference of the circle. Tangential to the circumference of the circle. All right. Okay, next, go. This one, differentiation, nothing to say. Very good. Your proof is correct as well. Here, this one, here's an analogy. Okay, sometimes you want to go and find a girl. How to find girl? You can climb up a mountain and go down the other side. And then you get stuck on the mountain, very dangerous. Or you could take a smarter way, take another route. Curve around the circle. When one path is too difficult, try another one. When upper minus lower doesn't work, what do you try instead?
Right minus left.
Right minus left. Yes, it will be easier. Okay, what your setup, what you call the setup. By the way, in the future, if you do physics, you always or engineering, you always hear this thing called the setup. You set up the equation, then this part is solving. But there's a problem here. The solving step is too difficult. Okay, the solving step is too difficult because I haven't teach you how to integrate ln. That's for H2 max. Actually, this one maybe also too difficult for H2 max words, but quite difficult. But then so it's too difficult. What you need to do is to use the righter minus lefter idea instead. Right function minus left function. Okay. Here this one, okay, not relevant. I'm just trying to come up with an example of upper minus lower, and to remind you that even though you can have regions of the graph that are both above the x-axis and below the x-axis, as long as you are bounded in between an upper and a lower function, you can always use integral of upper minus lower dx. This formula always works. It disregards, it ignores parts of the graph that are okay. Okay, I shouldn't say ignore. I mean, it isn't not affected by regions below x-axis. Because typically, if you have region below x-axis, the integral will become negative. But here, using this formula of upper minus lower, it just doesn't get affected. Super powerful formula. But here, anyways, the main point is you need to right minus left. And when you have right minus left, who is the subject here?
Y.
No.
I mean X. X equals to what?
In terms of Y. X equals to something in terms of Y, right? So here, let's take a look at this region, this diagram. They are asking for the region A, right? Calculate the area of the region bounded by the curve, the line x equal to 3, and the x-axis. So it's region A. Can you see region A here?
Mm-hmm.
And I also label a region B here. Yes. No. Ln 3, yes. So from there, if you want to solve for A, you just have to find B first, then minus. So now B, how to find?
Change Y equals to, oh my gosh, is it like this?
Okay, good. And then opposite of cube root is? Yep.
Okay.
Righter minus lefter, I highlight for you already. Can you tell me what color is it? Okay, yeah, you got it. It's green minus purple. Right? Yeah, can drop it. Then what's the limits? Y equal what? Y equal what? Yes.
A is 1/3 A.
See, now it becomes so easy to integrate. Yeah.
Then you take A plus B. You take ln 3 minus whatever you go.
Yes. Very good. Okay, just need to remember for me, e to the ln of x equals to
X.
good. Ln to the e of x is
X.
also x. Here, what if I have, say, e to the, what was that just now? We have like 1/3 3y. If I replace with 1/3 ln 3, what happens? 3 and 3 cancel away, you're left with 1/3 times e to the power of ln 3. What's e to the ln 3? To the power
E to ln 3 is 1.
Very, very good. So 1/3 times 3 becomes a 1. Yes. Okay. Yeah, so hopefully you can work out the rest on your own. This is enough hint already.
Okay.
Continue. Yeah, you actually got it already. I saw your working was fine. Good. Moving on. Next one. Trick. Wait. No, this one nothing to say. The principal value is fine. It's just a reminder of what is principal value. So you have sine x, cosine x, and tangent x graph, right? The part that I boxed up in blue is your principal region. Okay, principal value is referring to the x-axis, the allowed values of x, the angles. The x is the angles. Okay, allowed values of the angles. Why is so special about these blue color regions? It is a one-to-one function. What do I mean by one-to-one? So you must first understand what's many to one. For example, y equals to x squared. What happens when you have x equal -2? What's the y?
4.
What happens when you have x equals to +2? What's the y?
4.
It's also 4. Okay? Two different x values gives you the same y value. This is known as many to one. Many different x gives you one y value. Here, what we are doing is we realize that for sine, cosine, and tangent, it's extremely many to one. Extremely many to one. Like for example, you just add 2 pi radians each time, and you get back the same y coordinate, right? Sine of 30 degrees is equivalent to sine of 30 degrees plus 360 degrees, which is the same as sine of 360 times 2 is 720, and so on and so forth. Or in other words, sine 30 is really just half, right? Correct? I can think of it like this. I have sine x here, y equals sine x. When x is 30 degrees, what's my y value? It is 1/2. When x is 30 plus 360, what's my y value? It points back into the same y value. When it's 30 degrees plus 720 degrees, what's the corresponding y value? It's also pointing back to half. So many different x values to 1. That's very confusing, because if you want to reverse the direction of the arrow, like integration, like you have many possibilities. You need a plus c. Cannot, too confusing, right? So that's why we try to make things simpler by introducing this idea of principal domain and principal region with a principal value, and with a principal value. That's the correct phrase. What's so special is that in the blue box regions, the function now is no longer many to one. It's simply 1-to-1. Let me write down 1-to-1, and then I'll use my blue highlighter to box it up. One single x has only one corresponding. One single y value only has one corresponding x value. Can you see that? So it's like a unique pair. It's like a unique pair. Right? X, y, x, y, x, y, they're all unique pairs. There's no two different x values that give you the same y value. Okay? We don't want many to one, we want 1-to-1. We want 1-to-1. Okay, that's the reason behind this idea. And but you don't need to really understand so much. This is a bit of H2 math already. You just need to know what is it? You just need to know the corresponding region, and when you want to cosine inverse, you find the corresponding angle. You don't give values that are too big into 2 pi. One way that you can help you to remember is to remember that for sine and cosine, they are well behaved. They follow the same pattern. What is this angle? This is -90 degrees to +90 degrees, -pi/2 to pi/2. Right? They are the same. But for cosine, it's a bit naughty. It's always a bit different. Shift 90 degrees to the right. Similar to your negative angle identities. Sine minus theta, tangent minus theta. Yeah, you can take out a negative. You can take out a negative for sine and tangent. But for cosine, they try to be different. It's cosine of theta. Cannot tapao out the negative one. Yes, this one can tapao. All right, so likewise for the sine, you remember cosine A plus minus B? It becomes cos A cos B minus plus sine A sine B. Plus minus become minus plus. Cosine always gives you trouble. Cosine always gives you trouble. Something different. Plus minus become plus minus. It becomes minus plus. They always misbehave. Okay? That's the nerd morning. It's not really math. It's just to help you to remember things only. The intuition. And over here, the part B, totally irrelevant to part A already. X, Y, and Z are three angles of a triangle. Good diagram. Given that X and Y are acute angles, such that sin X equals 8/17 and sin Y equals 3/5, find exact value of tangent Z without the use of a calculator. So first thing you need to remember is draw the right angle triangle. Remember this kind of diagram? Sin X equals 8/17, draw right angle triangle. Then you can find the remaining length using Pythagoras theorem. Right? Then tangent X is what? X is an acute angle, remember? So tangent X, you don't have to stress about a sign. Opposite over adjacent, 8 over square root, whatever. 17 square.
You don't have to stress over this.
Yes, because sometimes they will tell you that X and Y. Sometimes they'll tell you what? Sine X is positive, cosine X is negative. Then, okay, wait, hold on. ASTC. Then what is the? Then you need to figure out that if X sine X is positive, that means that X is in the quadrant something and something, right? You remember this kind of questions? If cosine is positive, if cosine is less than 0, negative, that means the angle is in Q2 or Q3, right? Then overall, the overlapping region is X is in Q2, sorry. Remember this kind of logic?
Yeah.
That's required if they never specify the which quadrant X and Y is in, the angle X and angle Y. Lucky for you, this question is simpler. They just straight up tell you acute angle in between 0 degrees and 90 degrees. Comma Y. Okay. Don't comma Y, I'll write it as a separate line. 0 degrees less than Y less than 90 degrees. Okay, translating the English into math. This is the math notation. Okay. Yeah, that's for the sin X. This one. For the sin X, draw right angle triangle, then find tangent X. Likewise for your cosine. Likewise for your likewise for your sin Y. Can you do it on your own? This one?
Yeah.
Can, right? Okay, once you have that, you can also find tangent Y. But why? Why do I want to find tangent Y? It's because of the following thing. The question actually asks you for what? Find the exact value of tangent Z. So over here, tangent Z, do you realize that Z is just a third angle of a right angle triangle? Of a regular triangle. So Z equals to 180 minus away bracket X plus Y.
Oh, then you use identity.
Yes, correct.
You use I forgot what that identity is called.
Compound angle. Tangent A minus B. Okay. And 10A minus 10B over 1 plus 10A. Just refer to the formula list. Okay. Right. Good. Yeah. Then from there you can simplify. 180 degrees. You can type in a calculator. You get a 0. So eventually it becomes negative tangent X plus Y. Right. Good. Can. Then tangent X plus Y. How to find? That's when you need to use your compound angle identity again. Tangent X plus Y. It's tangent X plus tangent Y over 1 minus tangent X tangent Y. Then what's tangent X plus tangent Y? Then just sub in from the two right angled triangles. And then you can sub in. Okay, I think you get how to solve already.
Okay.
Right? Don't solve now. Do as homework already.
Yeah, I can.
Can. Okay, question 10 was fine. Nothing to say. Question 11. Then we're done.
Okay.
11:30 already. Okay. Yes. Okay, thank you. That is all I have for you today. I will send you your homework for kinematics and that will be it. Okay. Let me just stop the video first.